Yeah, if I was a doctor, I would prescribe you ice cream. That's how important it is for you to eat some. Okay, now the YouTube stream is up. Um, okay. That's why you're the mathematician? Nah, my, I'm an amateur doctor. You know, it's like my side gig, and definitely the prescriptions that I write are completely valid. Just bring it down to like Walgreens or whatever. First year advanced physics. I don't. What? Why do I click on these? Oh my god. Hey, syntax error. To pressing limit as x tends towards 0 from the right, your school will use the chance of me being loved? Aw. Well, I don't know. I I feel like I don't know. That's a funny joke. I don't know what to say though. Welcome in though, syntax. Yeah, I shouldn't look at this, right? This is stupid of me. You've got a pulley, you've got an incline, and you've got a spring here. I mean, it depends on the function, right? It's kind of what I was trying to figure out in my head. Like, you could have like 1 over x as it approaches 0 from the right. It does increase to positive infinity, so. This one has no responses. Oh, it's one of these translating a Riemann sum to an integral problem. Whoa, what's happening here? What? Oh, and yeah, Oak Spear. I saw that you were DMing me, but let me actually check it now if you're hanging out. Catenary? Yeah, I think that those are the hyperbolic trig functions, right? Oh, okay, Oak Spirit. Thanks for letting me know that. That is a cool graph. It looks like eyes that you sent. Guess you need to learn to do it by hand. Fair enough. Hey, SPQ. So made the mistake of Googling. Oh, yeah. Syntax error. That's what I said. It's in Google searches. That sounds really bad out of context. Elliptagon.com. All right, let's see what you have for us. I mean, I don't know how you derive it. Like, are you asking like the physics? Oh, well, this seems like the exact thing that you want. I don't know if the video's any good, but well, I guess I can link the Copy link address. Is that the YouTube link? Okay, yeah. So I don't know off the top of my head, but let me see if I can find an explanation. The fuck is Cinch? Did I skip a math class? Oh, I feel that. Okay. Thinking about trying to calculate E from the shape of a hanging rope. Hmm. Hey, minority suspect. Um, yeah, so it's like you're in like interested in the derivation. Can we find maybe a written explanation because I don't want to watch a YouTube video? Oh, like you get a shout out on the school's socials? That's nice. Catenary. The process to build this curve is fairly subtle. First, create a rotated hyperbola with x squared minus y squared equals 1. Instead of using the hyperbola, make a graph of just the x-coordinate. What do they mean by just the x-coordinate? Yeah, the video might be the best bet. Um, I I don't completely understand the explanation that this site has, but it could be another like resource. I guess this is the result of a differential equation is what they're saying. I really don't understand the setup here though. Just kind of throwing things out there without really explaining them to me, but I don't know. So yeah, it's not something that I know off the top of my head, but at least I can get you a few resources. Let's remove something is freaking weird. I don't want to look at it. If I solve the equation y of x and find y prime of x, set y prime of x equal to 0. That would work, Oak Spirit. If you already have like a first order diffie-q though, you can just take that and set it equal to 0 as well. Because you already have an equation for y prime. If it's like a second order, I don't know if that same thing would really work, but if second order you have to solve, I would think so, yeah. Let's maybe if there's like a certain form that the second order takes, maybe there's a trick, but I imagine you would have to solve it. Oh, physics and depression. Okay, yeah, that's a great person to to ask about it. Hey, for all your physics needs, highly recommend you check out physics and depression. I actually that textbook that you shouted out for electromagnetism, I did find it and it looks really interesting. I think I'm gonna try and go through it at some point in the next like month or two. At least I'm gonna like start on it. So thanks again for like helping me out with that. Let's look for. Oh, you know what? Syntax error might be watching the video, so Hopefully they'll come back and see that message. Confidence interval help. Let's see. Oh gosh, the Inspire. I don't know how to use that one. I don't remember how to use the normal TI-84 either, to be fair. This should be something you can Google though, right? TI Inspire confidence interval. Unless it's not that fancy. I also recommend Purcell's treatment of electro. Oh, it's a fancy one? Okay. Because unusually introduces special relativity almost immediately? Ooh. That's interesting. Let me write that one down. Where's my list? I have a little text file with textbooks that are at least somewhat interesting to me. Let me add that one in there and get the PDF later. Purcell's E&M, and I'll find it later. Okay. Thanks for adding that one on. Because in the same way that Penn Center is doing the abstract algebra reading group, I think it'd be kind of cool to do a reading group to go through like one of those physics books. But I feel like most people, at least around the stream, aren't too interested in physics, but I kind of want to do it anyway. Minority suspect, you posted a question? Let's see. Inverse trig integral. Should get one because you can't do algebra. I mean, you're in such an advanced class. Did you like get thrown into that class? Because I hope by that point you got some pretty good algebra skills if you're getting like, if you're doing like Lyapunov stability. That's like one of the last things I ever did as to get my math major. That's probably my favorite thing that I did too. I just can't remember it. Oh my god, dude! I was looking through my old notes. There was so much stuff that I was doing that I just completely forgot. Like I was literally doing like PDEs, like the heat equation, the wave equation. You're just doing comp sci? You have to do that, and you're doing comp sci? What kind of crazy like university are you going to? Oh my god. Yeah, that's some pretty high math requirements. I feel like the comp sci students at my university would just have to do like calculus and linear algebra. Teachers tries to make it as hard as possible. God, yeah, that's a lot to deal with. All right, so minority suspect off the bat, I see that I think the 25 needs to get square rooted when it comes out of the square root here. Like, so it should be 1/5. Let's see what else you did here, though. You're taking tangent x equal to sine theta. Is that a good idea? I think it is. Actually, no. Is there a better thing that we can do? Like, what's our Pythagorean identity? Oh, if it's what? Yeah, I guess you do need it to be with sine. Huh. That's an interesting sub. I don't think I've done a use sub quite like this before, where they're each functions. I don't see anything invalid about it, though. Because that does get you a nice cancellation. Wow. So what's the answer supposed to be? Because I kind of want to work this one out on the board. But I don't want to... Oh, you see what you did? I mean, this one over 25 is definitely wrong. I don't immediately see what else is wrong, though. Oh, wait, because of the sub, it should go back to being 1 over 25. That's kind of funny. Or no, it cancels out. Wait, dude, this dx thing is messing me up. You would say dx is equal to 5 over secant squared x. So yeah, I think the fraction would go away. Yeah. So this 1 over 25 should be 1 over 5, and then this 5 should cancel with that 1 over 5. That's a neat like technique to do this. Shouldn't secant x remain in the numerator? We multiply by cosine x. Yeah, cosine over cosine. With the idea of, ooh. I mean, I guess if you're talking about taking this original one, multiplying by cosine x over cosine, or I guess you do cosine squared. Okay, yeah, no, because you definitely do get a cancellation of the secant squared, so I do like this technique, but yeah, multiplying by cosine over cosine makes things kind of tricky unnecessarily. Huh, how would I have done this if I didn't know that you could, or I didn't realize you could do a sub like this? I think I would have, probably taken u equals tangent x, or probably 5 tangent x. Oh, no. Minority, this is a great way to solve the problem. I'm just kind of curious about it because it seems like a fun one. I kind of want to do it on the board the way that I would think to, but I think your way is completely valid. I don't see anything wrong with it. I'm just kind of curious to work it out the way that I'm more like used to. So you don't have to pay attention to this part at all. I'm just doing this for fun. Wrong? Oh, Ben. It's like I only just wrote I wrote integral and s and I'm already wrong. Okay, there we go. Love the bait. Hey, Eldritch. Yeah, it's math in time. So yeah, I probably would have said that u equals 5 tan x here, so that du equals 5 secant squared x dx. And that would mean we get 1/5. Secant cancels. The 5 came out there, so it's 1 over root 25 minus 25 u squared. So you have to do a second level of trig sub on this, but so I guess that's why your way is probably more efficient because you just cut straight to the chase here, whereas I definitely don't. It's kind of interesting. I hope that this, because we're gonna get, if we factor the 25 out, we're gonna get 1 over 25 out front. I assume it'll go away later though. I hope it will. So yeah, here we need sine to get involved. So let's take u equals sine theta or cosine, but I'll take sine. So du equals, why did I say minus? Just cosine theta, d theta. So we get cosine theta on top for root 1 minus sine squared theta, which is just cosine squared theta, d theta. So we get 1 over 25 cosine theta over root cosine squared theta, is just cosine theta, so let's call that 1 d theta. Let's get 1 over 25 theta. unsub to get 1/25. Arc sign? What's gonna happen to this 1/25? Then u becomes 5 tangent. Plus c. So I got the wrong answer. Yeah, so anytime you do two u subs, you can always like cut to the chase and like go straight to one sub. Like you've technically been inefficient, although it's easier for us to see it when it's easier for me to see it in two separate steps. But I got the same like wrong answer that minority did. I'm going to sleep, guys. All right, Eldritch. If you send any link, don't click them. Okay. Yeah, my minority. I'm glad that we found the error there. Should be 1/5 tan x for the u sub. I don't think so. Inside the arc sign. No? Unless I'm missing something. I definitely did something wrong, so I guess I am missing something, but... U is 5 tangent x, so there's a reason to flip that 5, unless I named the wrong u in the first place. Which is completely possible. Hey, Fenbox. How's it going? Hey, VFX Genie on YouTube. Do you need help with the problem, or are you saying you're lost with the problem that I'm doing on the board? If you're lost with the problem I'm doing on the board, I wouldn't worry about it, but... Minority, yeah, so... what I'm doing on the board is like just like for fun, for my own exploration. I think we found the error in your work, and you did a completely like valid way. So the fact that I'm getting the wrong answer here, I wouldn't dig too deeply into. I was trying to spot the error in my own work, but you haven't done anything wrong now that you fixed that. Lost with the one on the board? Yeah, I'm kind of lost with it too, to be honest. What the heck? Why is this so disgusting? What? Did I type something in wrong? Are these somehow like equivalent to the answer that minority got here? Oh wait. Oh, I see what you're saying with how it should be an over 5 for the tangent. Oak Spirit. I wonder. I see. I thought you meant there's an error in my work, but you're right. Like the answer that minority got does have the over 5. That's what you meant. Yeah, sure, Penbox. So like, I think we already got to the right answer for minority suspects technique. I was curious about getting to the right answer with this technique, and I clearly haven't. My 5 was in the wrong place. I wouldn't be surprised. should have done times 5 and when your homework gets that hard, you're done for it. Nah, Genie, it's also something you build up to. So hopefully if things are like well structured, when this comes up, you'll be ready for it. Or if it comes up. Hey, it's G1. You'd have u squared over... I would? Why? Oh! Hot. Nice. Of course, I was applying the sub wrong. Because we want it to be 5 times u, so we can do this thing. But, you know, we have tangent x and we have tangent x there, so we multiply each side by 5 there, or we keep it as 1/5 on this side. Okay. So that... so how does that change things? This becomes a 5 out front, and that's how we get our cancellation. I see. That's a tricky u sub. So 5 out front, we said. And then in the next step, we factor the 25 out, and then we don't get even a coefficient in front at all. And then down here, it's 1/5. Okay, nice spot. First u should be tan squared. The sub works better if it's not, I think. Because if you use tan squared, then you don't get that cancellation with secant. You're terrible at u sub, no worries. Yeah, if you do u equals like 1/5 tangent squared, you get a horrible derivatives. Will be like 2 tangent x times secant squared x, and then you don't get the nice like clean cancellation with the secant squared x. You do get a cancellation, just you also have a tangent left over that you don't want. At Trig Sub, I mean, this is an especially like tricky problem. We've been taught to recognize of the inverse functions. Video's pretty neat. Oh, nice. Oh, and syntax error. So you're probably busy watching the video, but physics and depression was just here and offered potential like help on this too. Physics and depression does also stream. I'm not sure when he'll be streaming next, but he was in chat before, at least offering help as well if you have any like questions. So yeah, my minority suspect, we really did it in the same way. Like anytime we do 2 u subs, we could have just cut straight to the chase, where if u is 1/5 tangent x and u is sine theta, we could have done 1/5 tangent equals sine theta, which is basically what you did. I just wasn't taught to like do it that quickly, but it saves work if you can spot that. So if you're comfortable doing it the way that you did it in your work, I recommend that you continue doing it that way, because it is more efficient, for sure. Yeah, no worries. If you have more questions, feel free to keep them coming. Got a bit lost at the end of the constants. You'll try to figure that stuff out. Teachers are striking, so you can probably try that out at home. Oh, okay. Sounds good. Oh, okay. Someone else help this person out. Sum of infinite series versus limit at infinity. Let's see. Oh no. The Romano-Jones sum. Sorry, I always pronounce that wrong. I don't remember how you're supposed to pronounce it. r/learn math. Oh, do you look at like the math help like subreddits too, Fembox? I used to make much more of a point of doing it, but it's just so tough to find questions on the forums sometimes. Or rather, like the questions are out there, but other people will answer them before I figure it out, or yeah, it's just like weird stuff. You mentioned never spent. Oh, okay. Yeah, I have like I cycle through like these like first 4 subreddits usually, and then if I don't find anything, I've been going over to algebra stuff. Because after teacher strike ends the next day, there's a student walkout. Wow. No, yeah, Reddit's pretty. At least the mainstream subreddits are pretty terrible. But I still spend time with them because I don't know why I do, but I shouldn't. The niche ones are pretty cool though. What? Unexpected factorial. Oh yeah. So my guess is that this person is new to the idea of series. Maybe they haven't, if they are taking a calculus class, they haven't gotten to that part of it yet. So you can try and, oh, see, this is white. Let's see what this person said if I have anything to add on to it. So work with a tutor who would just read Reddit all day when he didn't have students coming in for hours. He'd have like 50 tabs open. They think he's mainly pictures of cats. I mean, I'm all in favor of looking at some cat pictures. So yeah, it is a nice time waster. I know, I feel like if anyone lives their life never wasting time, then I don't understand how they're living. So it's at least a time waster of choice for some people, but other people prefer to waste their time in other ways. And if people are just being completely efficient with their time, then I guess hats off to them. Yeah, there's quite a few like math subreddits. I probably, I'm complaining about not being able to find enough questions. I probably should look for more, but I'm lazy. You think you've invented new gamma function rules on there? I think there's a lot of people who have posted supposed new types of math on Reddit, or they're like the subreddit for the Collatz conjecture is apparently a bit of a mess. With people thinking that they proved or disproved it. I don't know enough about it to judge either way. We're always, yeah, exactly, Fembox. The integral of secant of 3x. Well, it should be the integral of secant, but with a change of variables. Or not? Oh, does Wolfram... Is Wolfram doing a triple angle with secant? The greatest post ever was disproving the Collatz conjecture with 2 adic numbers. Well, congratulations, I guess, you know. I bet what happened, or I bet what's happening here is you take, this is minus ln and that's plus ln, so you can take this and divide it by that, and you should presumably get the same answer. I couldn't tell you exactly how. Let me actually find this for myself. Secant of 3x dx. Yeah, look at that beast. Assuming a complex valued logarithm. So yeah, the thing with logs as a result of an integral is you can get very different looking logs that are actually the same thing because the constant of integration makes things kind of weird. And so I bet their answer is correct. And I think the best way that, or I think the best thing I can tell them is to try deriving their answer if Wolfram Alpha isn't doing the same way that they are. Ln. It's always, when you write secant x, it's so hard to not write sex. I'm sorry, but like, yeah, I keep on acting like nearly doing that. Yeah, so it derives back, so you're fine. I think that Wolfram Alpha is saying that secant is 1 over cosine, and there actually exist triple angle identities. That's my guess for how they're doing it. So they probably use one of these. Someone took me seriously when I posted it on April Fool's Day. It's funny. Yeah, so overall, they may have done some other thing too with like, they took the final answer and then manipulated it, but usually they list what the other versions were too, so I'm betting that it was a triple angle. You know, I mean, trig identities kind of suck. It's all memorization. Derive, or take the derivative of your answer. Good check, and yours certainly works. You have to be careful with logs and trig functions with integrals because of the constant of integration. You can get different looking answers are actually the same. For example, if you have ln of 2x plus c, you can use log identities to say that it's also ln 2 plus ln x plus c. And since ln 2 is a constant, you could absorb it into c and also get ln x plus c. So that's why logs are kind of tricky. Paul's notes actually has a little page on this, which made me even like realize that in the first place. I feel like my example is probably slightly wrong though. I want to see the exact example on this site. Yeah, it's probably better to stick a 1/2 out front. Hey, Cruz. Just started number theory. If you have nothing better, mind going over Euclid's algorithm. I can. I need to remember Euclid's algorithm though, like exactly how it works. Let me Google it. It's something that I should know, but I can never remember it. But yeah, exactly. It's as Fenlock says, it finds the greatest common divisor of two numbers. Yeah, 'cause, like you divide them, but then it's the reverse part that I forget. Because you have to like go back up the list and sub things out, if I remember right. Like you would take this step and then you start plugging it back into the equations above. '97. So here they're finding the greatest common divisor 97 and 20. So start by doing like manual division with remainders and everything until you get to remainder 1. And then now what do you do? Wait, no, that's kind of a weird explanation. Like, just give me, actually, the algebra textbook goes over it, I think. Maybe I should just look at that. You want to go and take it to remainder 0. Oh, really? Really? Okay, apparently no one explains it in the way that I want to see it. Let me look at the algebra textbooks. I think they did it here too. Oh, was I being impatient? Does the textbook not go over that? Okay. So they do 803, 154, and then probably more familiar with is this, and then you take 154, shift it left. Oh my god, stop. And 33 and shift it left, and then you do that division, shift it left again, do that division, shift it left again, but then why don't they go back up the list? I thought there's like, this is only half of it, but they're saying. Really? You can just take this last number? That feels weird. I don't see if they're doing some extra work that avoids having to go back up the list. I thought you had to like do some unsubbing stuff. Hey, tired student. Oh yeah, so I absolutely would, tired student. I actually have music playing on Twitch, but on YouTube, like if you violate copyright on YouTube, I feel like they send a hitman to end your entire bloodline. So I don't play the music to YouTube. I need to figure out some kind of like copyright friendly thing if I'm gonna play it to YouTube, because what I have may or may not be copyright friendly. I can't confirm nor deny that. GCD AB returns the largest natural number such that A and B are both divisible by it. Yes. Oh, it's in Finnish? Yeah. So its greatest common divisor, so like the greatest common divisor of let's say 12 and 8 is 4, because 4 goes into both 12 and 8, and there's nothing higher that goes into them both. SYT for some reason? Oh. Yeah, I wonder if that's a translation thing. Okay, I mean, maybe I'm misremembering the Euclidean algorithm. I thought you need to go back up the list, but apparently you don't. So I can just show I can like work out this example even on the board here and try and explain it more. Have you seen anything translated in math? Oh, yeah. This is something I really should know offhand. It's just a bunch of like memorization though, so I don't bother. Or say I don't like use it often enough to have committed it to memory like naturally, I guess. All right, let's do green. Ah. So we're doing the GCD of 803 and 154. Okay, so syntax error. If you remember, like maybe you were first taught to divide numbers, you used remainders, which maybe in Finland it's phrased a little bit differently. But the idea is we're interested in the type of math that when we do this division, which actually is going to be a little bit tough to figure out, but we don't want a decimal. We want a remainder here. So how many times 153 go into 803? That's not mental math for me. At least 4 times, right? I'm going to guess that it's 5 times. Let's see how that comes out. I could look at the thing, I guess, but who cares? 770? Definitely can't get more in there, but did I do that math right? Oh, bam, it is 5. Okay. And you get 33 left over? Okay, good. 33. So rather than like doing 0.0 and dropping a 0 down to get a decimal, we're just going to stop here because we have 5 with remainder 33. And we don't usually write it like this when we're doing Euclid's algorithm, though. We write it as like multiplication. So if we know that this is true, we also know that this equation, 803, is equal to 154 times 5 plus 33. So you can see like each of the pieces here appears in this equation as well, and they're like basically they're completely equivalent statements. But I think it's important to kind of have that, yeah, A equals BQ plus R, exactly. Hey, Gold. Oh, nice try. Yeah, I was about to say 4. If you haven't seen this method before, it's called Euclid's algorithm. You probably have seen it somewhere. I personally don't have it memorized, so I just spent like 10 minutes like Googling it, but it's a thing where like you take these numbers and you shift them over. I feel like it's pretty commonly taught. So yeah, we take them, we multiply by them in the remainder, we shift them over, and we repeat the process. So we need to find 33 times what plus something else makes 154. So I'll do it off to the side here again. Oh, actually, that's not really that helpful. If we multiply by 5, I think that's too much. So let's try 4. 2, 1, 13. Yeah. So you get 2, 2, 22. So 4 remainder 22. So 33 times 4 plus 22 is our next equation. And now we do the same shift, and we go again. 22 times something plus something else. Here we can just see 22. We can't do 2 times 22 because we go over. So let's do 22 times 1 plus 11. Shift one more time. Now we get 22 equals 11 times something plus something else. Well, 11 goes right into 22, so let's do 11 times 2 plus 0. And you get a remainder of 0, that's when you stop. And apparently, our last non-zero remainder is just the GCD. So we'd say that the GCD is 11. That part, I don't remember it being that simple, because that's what the website is saying. That once you get remainder 0, just back up a step, take that remainder, and you're done. So why did I choose 5? Because 6 is too high. You want to choose the highest number you can without going over. It's like Price is Right, I guess. Yeah, so like I remember like when I was taught, it's like you have to like go back up the list and do some weird like substitution stuff. Maybe let's just find the linear combination maybe. But the actual GCD we already know. Oh, you realized it already? Hey, AS Gaming Bros over on YouTube. How's it going? I know that it helps you build the GCD as a linear combination of the initial two like numbers. And I think that's why it works. Because if you can write a linear combination of two numbers, that's their GCD, or that makes it a number, that other number is their GCD, as long as there isn't a smaller one. And I think that's why it works. This is the type of math that I'm not very familiar with though. But so yeah, syntax error, I hope that helps like explain the algorithm a bit more. I'm happy to do another example if it helps. But out of curiosity, I kind of want to figure out if I can do that linear combination thing. Sweet. I think the thing that I'm thinking of with reversing the steps is if we want an equation in the form of like 803a plus 154b equals 11, we can figure out the a and b based off these steps. And I think it's something to do with like subbing. I think we take 22 is equal to 11 times 2 and we plug it in there. But let's just try that and see if we can reverse engineer this. And then we want to sub for like 33 in the next equation up, right? But we want it to be slightly different. This feels weird though. I feel like I'm already wrong. I see prior to reading the chapter, you're dyslexic, so you try to watch videos. Oh, interesting. Yeah, I'm happy to help like try to give you like a primer on this stuff if it helps you understand it. You know what? I feel like I should know how this Euclid's extended algorithm, the second to last. Oh, okay. So if we start with the second to last equation, and I assume we want to sub the 22. So we say, yeah, okay. We'd say that 154 is equal to 33 times 4 plus 22 is equal to 33 minus 11, I think is how we want to go about this. And then we can combine these 33s. So remember, you have to do some kind of like combining thing here. Okay. Do we want the 11 here though? I feel like we don't. Oh wait, yeah, we do want the 11 here. So we want to get rid of the 33 because we want to build towards, okay, wait, let me just, we start with the second class equation, we come up here. We can express 33 as 154 minus 22? Times 5 minus 11. So we get 154 equals 154 times 5 minus 22 times 5. Make it more clear, it's minus 11. We could bring the 154 over and the 11 to the other side and get 11 equals 154 times 4 minus 22 times 5. And now we go up another equation, maybe? Well, we have the 22. That can't be good. We need to get rid, we want it to be a 33, because then we know what 33 is. You good, ASK Gaming Bros? Awesome, glad to hear it. Yeah, Fembox, you're right. I heard we need to be able to program this in Python for the final exam. Are you thinking of doing some fuckery? I could do it in C. Too limited by technology. ASK Gaming Bros, can you try trig identities? I can, but you can be a bit more specific, because that's a pretty big topic, and I don't want to start explaining the wrong thing. So wait. Let's number these. Okay. Why am I... Why did I start with... Did I start with this one? Shouldn't I have started with that one? Oh no, I did the mental math. Okay. See, I want to get rid of this 22. It's the moral of the story. I feel like... I'm doing this in a really inefficient way. Like, didn't I already... Okay, this was for plugging 3 into 2. Right? And then we rearrange it. And then we involve equation 2 again. See, now this is where it's weird, dude. I don't know, but that's why I can't remember the algorithm. It's so weird. From the left-hand side. AS Gaming Rose, yeah, like the general idea is you want to use the more complicated side and try just kind of randomly applying identities until you see the patterns. If you can give me an actual problem like that, that really helps me out, I guess, because like even probably you already understand, I can talk through like my thought process and how I approach it. But it's kind of hard to just like choose one out of thin air. Now, why am I getting stupid here? I guess we're getting multiple 11s, so if I say that 22, yeah, I feel like I should be able to do this way more efficiently, and I'm not. Did I go wrong at this step with the 33? Oh, wait, yeah, maybe I did the wrong sub. We know that 33 is 803 minus 154. Maybe that's the part where I mess up. Because I did 3 into 2, and now I need to do 2 into 1. That's why I hate the extended Euclidean algorithm, because I can't remember it for the life of me. Like this. So we're saying that 33 is equal to 803 minus 154 times 5, and then we have the times 5 on the outside. And hopefully this gets us where we want to go. I don't imagine this to be that bad to code once you understand the process. It's just for me, this process is so weird. Evidently that I just have a hard time remembering it. No, 26. So I think our linear combination, which we should verify, is that 11 is equal to 803 times 5 minus 154 times 24. And let's pray to God that that equals 11. Oh my God. Oh. Even though that was painful, like I feel like it's good to actually work that out. And let's hope I did it right. $319? Wait, it's 26, right? 11. There we go. I accidentally subtracted 1. It was a negative 25 minus 1. I did negative 25 plus 1. Yeah, Milk. So I probably just piled onto the confusion, but syntax error asks a question about using Euclide's algorithm to find the GCD of two numbers, which is the upper half of what I did on the board. And then I did the extended algorithm, or whatever it's called, which is the lower half, to find the linear combination, or the GCD as a linear combination. But I can never remember it for the life of me, so I was trying to puzzle it out just like intuitively. So eventually I got there. It just took me way more effort than it probably should have. Hey Phobos, they do, yeah. I can never remember, but I think it's called Euclide's extended algorithm. Prime decomposition, that works too. That can be a pain with big numbers, but it does work also. Euclid's extended algorithm. So the idea is if you want to take the GCD of 102 and 38 in this example, you just continually divide them in a way that like gets the remainders, and you do the shifting. So 38 gets shifted left and the 26 gets shifted left. You divide those two, shift the same numbers left again, divide, shift. And then for the extended part, you go basically back up the list if you want to build that linear combination. Oh. What? Dude, recursive functions are so weird. This gets the GCD, it's 2 lines. Oh my God, I wish I was better at recursion. That's so weird. You just keep modding them. Hey, Hada Aicha on YouTube? Welcome in. Trying to build the linear combination. Yeah, I mean, it wasn't clicking for me either, to be fair. Yeah, the extended algorithm gets this, and you basically have to sub numbers out until you build, like you start with the with this line. Oops, I can't highlight. You start with second to last line here, and you would say that I think this 12 is equal to 38 minus 26. And then you say that that 26 is equal to 102 minus 2 times 38. And you can group things together to get your linear combination. Okay, prove that cosine of 360 minus x. Oh, see, no, I wouldn't have thought that the problem with identities like that, was why I was asking you to give me an actual example. Hey, Gaming Bros, I'm sorry if I was being like difficult. Euclid's doubly extended algorithm that gives linear combination in the LCM. I guess if you know the product and you know the GCD, we have that identity that the product of two numbers is equal to the LCM times the GCD. So I guess you could do the product divided by GCD. But yeah, I don't know. There probably is a different way to get the LCM too. Yeah, I'll put the link in chat if anyone's like me and can't remember this algorithm for the life of them, because it seems like a good explanation. Okay, so it's a square root of 2, then x. So wait, you're saying square root, but I think it's tangent squared x. Let me write the problem on the board, and you tell me if I'm writing it right. Ooh! Oh my god! I stepped on my headphone cord. The world almost exploded there. Okay. Come on. All right, so you have the problem cosine of 360 minus x times tangent squared x over sine 180 minus x times cosine 90 plus x. Equals 1 over cosine. Have I copied on the problem right? While I wait to hear back, I'm gonna look at my trig identities. So my instinct is to use some different identities here. That's correct? Okay. So when I see this problem, I immediately want to deal with the 360 minus x, the 180 minus x, and the 90 plus x, because those are just weird. But they are clean unit circle values, and so they should come out to be pretty simple things like minus sine or plus cosine, or maybe sine times cosine, or things that aren't like too bad to deal with. You can technically kind of like logically work out what cosine of 360 minus x should be if you know like function transformations and you're comfortable with them. But that to me can get a little bit like tricky. Or it'll be easy for me to make a mistake with that. So the technique that I think to use here, where I'm much less likely to make a mistake, is to just use these sum and difference identities over here. And, you know, just split out the 90, the 180, and the 360. It'll be a bit more work, but I would feel much more confident using those sum and difference identities. Underscore. You know, those random tangents are the best, all right? All right, so let's try applying the sum and difference identities and see where that lands us. So we have cosine of 360 minus. So we're going to do cosine plus sine. Okay. So starting with that cosine 360 minus x. And with these, there's almost always a couple of ways to do these problems. So if you did it a different way, I wouldn't be alarmed. It's probably still good too. But this is the way that kind of jumps out to me. The tangent squared, I'm going to leave alone for now. I'm going to hope it cancels out later on in the problem. And also remember, when you prove identities, don't work on both sides of the equation. Choose the more complicated side and work with that. If you start multiplying things on both sides of the equation, you're making a logical error. Let's work with that sine 180 minus x. It's going to be sine of the first thing times cosine of the second thing minus cosine of the first thing sine of the second thing. All right, so that's that. Oh, my cam is still up. Oops. What was that noise? Okay. Then we have the cosine of 90 plus x to worry about last. So it'll be cosine minus cosine 90 cosine x minus sine 90 sine x. Okay. So this looks terrible right now, but we have 360, 360, 180, 180, 90, 90. Those are all nice unit circle values. So let's start plugging those in. Cosine of 360 is 1. Yeah. Sine of 360 is 0. So that's just 0 times sine and then 0. So I'm going to write 0 there. Sine of 180 is 0. Cosine of 180 is negative 1. There's a negative sign out front, so it turns to positive 1. Cosine of 90 is 0. Sine of 90 is positive 1, so we get minus 1 times sine x. All right, we're going another line down, get rid of these zeros and ones. So we get cosine x, tan squared x, sine x times minus sine x. Hopefully this is okay. I'm not so sure looking at this actually. I think I have a negative sign that's bad, right? I need to re-examine my signs, but let me just get to the last step and then I'll relook at my trig identities, because maybe I said this would be less error prone way for me too, but I think I still made an error here. We know that tangent is sine over cosine. So tangent squared is sine squared over cosine squared. The sine squared cancel with the sine squared. The cosine can cancel with one of the cosines. So we do get minus 1 over cosine x, which is slightly wrong. What can we do about that minus sign? Poor neglected left-hand side. So let's see. Let's make sure I applied my sum and difference identities right. So cosine 360 minus x. You don't see any mistakes. Oh my god, Fembox, you're right. It's sine of x minus 180. And that, oh my god, and sine's an odd function. Okay, so I flipped the order there. There we go. Hey, I'm on Garg over on YouTube. Hey, Jed. I'll look at that in a second, Among Garg. I'm almost done with this problem, and then I'll take a better look at that. Okay, so we need to switch this. We need to switch all of these. It'll be x 180. Oh. Schwax, thanks so much for the prime. How's it going? I really appreciate that. X and 180. Okay, and that means this bad boy down here. Cosine of 180 is -1. So you get sine x times -1. The sine of 180 is 0. And okay, so now you get negative sine times negative sine is positive sine. Now we've done it. So I did apply the identizer, I just didn't copy it down right. So yeah, I hope that helps you. Pop in and say hi. Well, thanks so much, Schwax. Hope you have a good day. And Ethio TikTok live game, once again, or once it doesn't see by camera, show that again. I don't know what you want to see again, Ethio, I'm sorry. I don't understand what you're saying. Okay, so AS Gamers, let me know if you have any questions on that one. And then in the meantime, I'll look at Among Gargs. You have 10 minus x equals 8. You're saying the answer is x equals -2, which I think is where things have gone wrong. So you're saying that we get, if I follow your work along, where you're saying we get x equals 8 minus 10. Which I think that's where we went wrong. I wouldn't say this is a true statement. So let's back up and solve this from scratch. There's two different ways that you can do this depending on how you're more comfortable. I'll show it this way, but if it seems weird to you, there's a different way that we can look at it too. I'm going to subtract 10 from each side to try and isolate the x. So let's start with subtracting 10. So you get -x equals 8 minus 10. But x isn't isolated quite yet. We have that negative sign in front. So we have to multiply each side of the equation by -1. So -1 times and -1 times. So negative times negative is positive, so we get positive x. Now the -1 gets distributed inside here. So it's -8 plus 10. So you get x equals +2. And so now if you take that and plug it back in like you were saying, you do get the right answer, which is 10 minus 2 equals 8. 8 equals 8, and happy days. Now, if that way seems weird to you, there's a different way that we could look at it too, but parentheses, I mean, you're right, Jed, but I think in this context it's fine. But yeah. I mean, I feel like it's implied when you multiply each side of the equation by that, but Yeah, let me know if you have any questions about that. I'm on. So we need to get x to be positive by multiplying both sides. Exactly, yeah. Awesome, AS Gaming Bros. So yeah, underscore. I was saying that we could try and do it like that. I shied away from that because it feels more error prone to me. Like I feel like I'm likely to make a mistake if I do it like that. It does save you a lot of time though if you can do that. For half an hour, it's an over. Oh wow, that's annoying. A Mongard. Yeah, sure, Ethio. The other way, yeah, it's moving the x over first, so you have to multiply through by -1. So yeah, like cosine of 360 minus x, and you can definitely do that with function transformations. Actually, that's just cosine of x, isn't it? Yeah. You too, AS Gaming Bros. And sine of x minus 180, that's negative sine of x. I guess maybe that's not that bad. Cosine of 90 plus x. It's either sine x or negative sine x. Well, I actually already know the answer. It should be negative sine x. That one's a little bit trickier to me. Can you just do it by looking at the unit circle? Like you say underscore? Like how do you think about it in that sense? That's not, wait. That's not one. So if you have cosine of 90 plus x, how do you use the unit circle to figure out what that is? If your x is, say, 0, then 90 plus x. Oh, the puzzle line notes one? I don't like that one as much, I don't think. I think I've looked at it before. Actually, I do like the period stuff. I do always forget this. And I think I have this downloaded on my machine somewhere. It actually might be a nicer one. I don't remember what I didn't like about it. Among our, do you stream on fixed time indoor days? Yes, I stream on Tuesday, Thursday, Saturdays, starting an hour and a half ago, whatever that is in your time zone. And if you're willing to go over to Twitch, there's a little math community of people who stream math over on Twitch. Ethio put something about logarithm? Yeah, like what about logarithms? Cosine of 90 plus x. So when x is 0, I mean, I guess you would say that you start from 0. Oh, that's 2:30 a.m. for you, geez. um, but yeah, I guess that's the time for you then. Wow, we're 12 hours apart? That's crazy. Or rather, oh no, that's the start time. Never mind. Almost 12 hours. Yes, like the cosine of 90 plus x is the one that's getting me there, which is why I didn't want to do it this way. But yeah, if you're good enough with like function transformations, you can definitely do it like that. Depressing complex cubic equation? Oh. Interesting. Ignore math's all my school, now you're in college and you're redoing math all over again. Yeah, it's a pretty common story, I feel like. So there's definitely no shame in that, Aman. So yeah, I guess best of luck to you as you like relearn math, and I'm happy to help if you have any more questions. The real cubic, oh wait, depression method? I never heard of that. I wonder if that's like Vietas or, huh. Euclidean geometry question, let's see. Altitudes are length 20, 25, and y? Ooh. No, I don't know how to do this one. Whoa. Eighty-eight is far too big. It does seem like a pretty big number. Actually, are they talking about like integers as well? Oh yeah, integers. I guess you'd have to do some kind of like, can you translate it into a triangle inequality? Like, what is the altitude of a triangle even? Does it give you a perpendicular angle? Because you might be able to work someone out. Okay, yeah, it's what you get when you go from an angle and make a perpendicular angle with the opposite side. So I bet triangle inequality will get you somewhere with that, but I feel like you have to do a lot of math to actually get there, and I don't really want to. What are the key properties of logarithms? Yeah, sure, Ethio. We can talk about that. I mean, so it's something where like you can Google it and see a list, but I'll do that and like kind of explain them. You get 5 and 40, or between 5 and 40. How'd you get it so quick? Underscore. I don't like that. There's a site that I've seen before that I kind of like how they... Oh my god. I just want it to be formatted in a way that isn't completely stupid. All right. All right, so I'll link this to you if you want to like have it for reference or something. Oh no, the link is too long. Never mind. But I'll just like go through and explain these a bit. So, oh, and zooming to what? Okay, now it works. All right, so actually, I don't like the way this is. Okay, I'm gonna start with the exponential property here, which is when if you have an exponent inside a log, like if you have log of 2 cubed, that cubed exponent can come out front as a coefficient, which is one that I feel like I use the most often with logs. So if you have log base b of a to the r, that r can come out front and get multiplied. That's probably the most useful one that I would have memorized. The change of base, you normally get quizzed on it if you're just learning about log for the first time, but I hardly ever use it. Hey, Zach. I'll look at that in a second, underscore. So yeah, I mean, the change of base, the way that I remember it is A is the number you write big, and so it goes on top. B is the number you write small, and it's a little bit lower, so it goes on the bottom of the fraction. And then C, you can choose anything you want. That's the whole reason that's called change of base, because you get to change the base of your log to anything you want. As long as A goes on top, B goes on the bottom. You've already gotten the sum of logs. These two we use decently. Like after the exponent rule, I'd say these are the ones that I use the most often after that. So the kind of, I guess, analog or whatever to the sum of logs is the difference of logs, which instead of, if you have a minus sign between them, you divide rather than multiply. Yeah, so I'd say those are kind of all the properties of logs that I think you really need to know. Working with logs can still be tricky. Like, it's good to be able to convert from exponential form of an equation to logarithmic form. Wait, Ethio, you just asked the question. I spent the last like 5 minutes talking about the key properties of logarithms, and you just asked it again? That's what I'm doing right now. Am I going crazy? See ya, Aman. Awesome. Yeah, I'm glad I was able to help you out. Critical, yeah, sure. Once I'm through this logarithm thing, we can get to it. B and A and C are both negatives. Oh, it'll be 1 over AC? Yeah. I never actually encountered that, but you're absolutely right. So yeah, Ethio, I say those are kind of like the most important things to know about logs that I just like talked about there. If that's a problem you want to see, please let me know. But if the question is what are the key properties of logs, I'd say those are the key properties of logs. Let's look at Critical's question. What's happening here? Why do I have to write a sub 1 there? You have 2 different images coming in hot. Are these the same image? Oh, they are. I just got double posted. Okay. Never mind. Why do I have to write sub 1 here? It's all good. Hey, Brian. What? Oh, what's like my glasses prescription? I don't know what it is. I have very bad eyes. It's a pretty beefy prescription. Like, I don't. I can't even see like how well it's showing up on camera unless I get right in there. My lenses are pretty thick. It's not showing up well on cam though. I don't know my exact prescription, but it's pretty high. So I guess the sub 1 where? You're talking about like why we need this A sub 1 here? Or what are you asking about? Critical. I don't know. Is this a part of a proof from your textbook? Can I see the rest of the proof? Is maybe proving the integral test? Bad eyes and bad dyes. Oh, really? So underscore got like what? 40 possible answers or 41. I think Critical's about to post the context. It seems like this is doing some tricky stuff just because they want to force an inequality to happen. But I'm not sure exactly why they would want it without seeing the rest of it. Do you feel afraid of working computer so much in that case? Yeah, it's something I've been thinking about. The last time I went to see the eye doctor, optometrist, or whatever you call him, they actually wrote me 2 prescriptions. One was a weaker version of the one that I have right now for when I'm at the computer. I didn't actually buy glasses that had that weaker prescription, though. I probably should have, but I forget why. But yeah, like looking at screens is definitely bad for your eyes. And I probably I don't really do too much to alleviate it though. Ethio, I answered your question. I don't know why you're saying that. Oh, I see you posted the context here. Okay. Oh, thanks, Ethio. Hardlocked, hey, how's it going? Be Italian. I think it says fragile. Thank you so much for the 8 months. Holy crap, why did I play that same alert twice in a row, by the way? I don't know. I don't care, though. Thank you so much, Hardlocked. See, this only looks like a proof of the integral test. Oh, so, okay, I think this is a Riemann sum. Oh, that's why it has to be decreasing. Okay. So yeah, this represents a Riemann sum, I guess, with 1. And because f of x is a decreasing function, which is a requirement of the integral test, you know it's an overestimation. Because we're taking a left-handed sum. So this isn't your question, critical, I know, but I'm trying to understand the proof, I guess, from scratch, and then I'll answer the question you actually had about it. All right, and so now we're considering the case where this integral converges. So we showed the sum from I equals 2. Really? Okay, well, I'm not sure what equation 4 was saying, but if I just take that as true, then we have that relationship. Okay, so I think I know enough to answer your question at least for why that a sub 1 is there. Yeah, I think I figured out the visual for the equation at the top. But no, I absolutely prefer the the visual way as well. For any problem, really, I'd rather do them visually if I can. All right, so they did skip a little step here, which is so S sub n is your partial sum from 1 to n of a series, and so you can always, like, forgetting out the context in the problem, you can always write the Sn as the sum from I equals 1 or whatever your starting index is to n of a sub I. Well, they want to use the inequality they established earlier on in the proof, and that requires that I equals 2. And so we can manually split out the first term to force that starting index to match. So I'll write out even the long way here. This summation is, if we split it out, is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus ... all the way up to a sub n. Now we'll keep the a sub 1 out here, and the rest of this will collapse back into a summation. But it'll have the desirable property of starting from 2, which is exactly what we want here. And so the reason that a sub 1 is there is because we need that I equals 2 on the bottom. It's the short answer. A sub ace? I guess you didn't see the sign. If that's a reference, I don't know it. The a sub 1 is going to be duplicated. I'm not sure what you mean with that duplication. Ace of Base, an 80s Swedish pop group? I can't. Yeah, that was a little too out there for me. And hey, Steely, if I'm saying that right, math? Yes, math. Why so many letters? Because that's just how math becomes after a certain point. Like a sub 1 is going to remain because the a sub 1 is not going to get canceled. Yeah, you could think about it like that. They established earlier that the sum from I equals 2 to n of a sub I is less than or equal to the integral from 1 to infinity of f of x dx. If I'm copying that right. Oh, 1 to n, my bad. And what they want is they want to find any situation where they can apply this inequality here. So they just look at the general formula for the sum of a series, and they notice that it's nearly what we want with I equals 1 rather than I equals 2. So in the spirit of getting to use this inequality that we worked to prove earlier, we pull the first term out of this sum to force this starting index to become I equals 2, and now we're allowed to use that inequality. So the a sub 1 just kind of stays where it is, but we're plugging in a bigger number over here, which is why we make an inequality. So like we're plugging this inequality in here, but we can't make it equal because it's not necessarily equal. So we convert it with the same sign. So this a sub 1 just stayed the same here. All we did was we subbed this out for this. Yes, Julie, if you have a question, feel free to ask them, but if you're just like chilling, that's completely fine too. Yeah, we're gonna question from it's like a second semester calculus class is when you see a question like this. So if you haven't gotten there, then it probably doesn't make much sense, but yeah, it's like hopefully educational. But you know, it's like the more letters are involved, the more general statements you get to make, which is why as you go farther in math, more and more letters get involved because mathematics like to make the most general statement possible. So I think about it. Yeah, critical, because we're interested in the entire sum and whether it converges or diverges. And the issue with the entire sum is that it starts from I equals 1. So we can make it start from I equals 2 if we take out that first term and kind of separate it out. But we're interested in whether the sum itself converges or diverges, so we can't just forget about a sub 1. It has to be included. But we can put it off to the side while we work on the rest of the series. Yeah, critical. If you want to make it I equals 3, you take out A1 and A2. And in this proof, it would be a bad idea, but it's valid to do that if you wanted to. No worries, critical. And yes, Steely, it's like a good amount of people who like will come in and just ask like, how do I get good at math? I have a test next week or something like that. And it feels like asking a bodybuilder, how do I get super buff? I have only 1 week. The real answer is it just takes a lot of hard work and time. You just have to get your math reps in. Although I won't consider myself like a bodybuilder of math, but it's just practice, 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 and you eventually build up. There, yeah. Underscore understands it. This one has a new comment. Let's see. Okay. Should we shift over to algebra? So I don't think we have anyone else asking a question from chat, and I don't feel like going on Reddit anymore. Let's come over here. There we go. Is this subgroup time? Yeah. So last night, I worked through a couple more problems from chapter 2, or chapter, no, yeah, chapter 2. This. So I think I feel comfortable enough moving on to the next chapter. The most complex way of calculating 2 times 2? I got you. Say no more, Steely. Well, I don't know if it's the most complicated. I feel like there's a more complicated way that someone could come up with. But here's one that comes to mind for me. So obviously 2 is equal to 1 plus 1, so let's sub that in. And 2 is equal to 1 plus 1, so let's sub that in. And now we can distribute these 1s out, so using FOIL. So this one gets multiplied by that one and that one. So you get 1 times 1 plus 1 times 1. Now distribute that one to that one and that one. Plus 1 times 1 plus 1 times 1. Now, we know that 1 is equal to 1 plus 0, so let's sub that in. I am mixing my multiplication notation, but who cares? I think there's a whole world of possibility that you could do to make this even more complicated than I'm doing, though. Equals equals. Now let's FOIL these out and get 1 times 1 plus 1 times 0 plus 0 times 1 plus 0 times 0 plus. Now we FOIL these out, we get 1 times 1 plus 1 times 0 plus 0 times 1 plus 0 times 0 plus. Now let's FOIL these out and we get 1 times 1 plus 1 times 0 plus 0 times 1 plus 0 times 0. Now let's FOIL these out and we get 1 times 1 plus 1 times 0 plus 0 times 1 plus 0 times 0. Now I think we're about ready to start combining like terms. So I guess I'll make the claim that 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. Plus 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. And 0 times 0 is 0. All right? So I would say that we have 1 plus, or I mean, no, let's do it like 1 plus 0 plus 0 is 0 is 1. 1 plus 0 plus 0 plus 0 is 1. 1 plus 0 plus 0 plus 0 is 1. 1 plus 0 plus 0 plus 0 is 1. 1 plus 1 plus 1 is 4. We can get even more complicated, I guess, but that's the, you know. Factor out the 1? Oh, yeah. An idea for subgroups with 2 times 2? Yeah. I was like, oh, there's probably some like abstract algebra way to do this too. Yeah, I'm writing machine code, exactly. Yeah, no, I was thinking of doing like, oh, well, we know that 2 is equal to the integral of like 1 over x from, so I couldn't figure out the bounds in time. So like, oh, let's just do this way. But yeah, so let's see. Last night I did some off-stream studying. I went through a couple more questions. Some of these proofs I tried to do, but I ended up looking at the answers in the book because they're just a little too tricky for me. I think we'll move on to chapter 3 though, which are finite groups and subgroups. Hey, thanks for the follow, Steely. 4 times 48 is something more than 1 plus 1 plus 1 times 1. Yeah, exactly. That's how the best math is done. And it's basically how computers do math, to be honest. So we learn about the order of a group, the order of an element, what a subgroup is, how you test for a subgroup. Are you sure we aren't in base 3? I mean, the answer's the same, isn't it? Oh, no, never mind. This would be 11 in base 3. Yeah, you're right. So what's up with the the one-step subgroup test is it's super unintuitive to me for why it works, even though I looked at the proof. But apparently it does work. So if G is a group, H is a non-empty subset of G, if you show that A times B inverse is in H, whenever A and B are in H, then H is a subgroup of G, which kind of messes my mind, but I can accept it as true. And then they gave this really helpful procedure for actually proving that a subgroup is a group, or that, your proposed subgroup is indeed a group. Y'all one-stepping? I haven't one-stepped yet, but hopefully I will. Probably have to refer back to this once I get to an actual thing. The two-step subgroup test, proving that it's closed, and then proving that each element has an inverse. And then if it's a finite subgroup, which I think you can take a finite subgroup of an infinite group and you can use this still. I wasn't really clear on that part from the wording, but it seems like the wording would allow that. Like, it doesn't say G has to be finite, just H has to be finite, so. You've heard that the ants once marched 2 by 2. They shouted hurrah, which has 4 distinct characters, not counting duplicates. That is a complicated way of doing it. Roots of unity are a finite subgroup under multiplication. So if you take all non-zero complex numbers, that's an infinite group. And you can get to finite subgroup if you take just the 1, negative 1, I, negative I. Well, no, I'm thinking about like generators right now. That's still infinite. Well, no, 1 I, well, whatever I just said, is a group contained in itself, right? Under multiplication. Yeah. I don't know if that has a specific way that you say that, but brackets A is every power of A, and that forms a subgroup. It's actually the least subgroup, or the small subgroup involving A. So if anything else involves A, then must involve that entire subgroup. Or I think you violate closure or something. If you didn't. Okay, I was kind of this example with integers. You could also have done this with positive 1, and you would still get all integers back out, because you include negative powers. I was a little bit confused why they included the negative 1. Well, I guess there's nothing, like, it's just an example like any other, but I think 1 or negative 1 would work. I remember that took me like a minute to wrap my brain around. A reads like the group generated by A. Okay, yeah, it's just like a little like wordy, I guess, but I guess it makes sense. Okay, thank you for that, Fembox. Oh, and this is the example that Phobos maybe said. Oh, wait. Okay. This explanation was terrible for me. I did not understand these words in the slightest. For when you have a group generated by two different elements, it's like you're taking like linear combinations of each of them. It's not just 8 individually unioned with 14 individually. It's any combination of 8 and 14 at the same time, which is also each of them individually, but so it's like here for the dihedral group of order 8 or 4 or whatever. I was confused why they had h squared, but not v squared. And what rationale did I come up with for that? Because, oh yes, that's right. H squared and v squared are both equal to r0, so it'd be redundant to include them both. But it was super confusing to me at first why we wouldn't also have v squared there when it seems like just as valid of a combination. Same with like VH. But it turned out to be the same as HV, so they leave that off too. Steely? Oh yeah. This is an extremely wordy version of math. So I guess like kind of the shtick of the stream is I take questions from chat. But if I don't have questions from chat, I'll do some like studying or some other thing. So right now I'm studying something called abstract algebra, which is there's not many numbers involved in this. It's very like conceptual relative to other types of math that you may have seen. When you're learning Java, I had nightmares on problems like 3 nights in a row. Oh geez. I think I've wrapped my head around what actually happens here. It's like this example helped me figure out like what the hell like this actually means with the whole like linear combination explanation. This one did get me curious if you could express every real number with some type of combination of irrational numbers, but I don't think you can. Or I doubt you can. All right, let's look at what you're saying, underscore. Okay, the subgroup generated by S is the small subgroup of G containing containing S. Being a subgroup of G containing S, then what does it mean to be the smallest? Well, I guess that was like the fewest elements necessary. But I was more confused on what this whole like, if you have the group generated by 8, 14, how do you actually do that? Which to me, this didn't explain it at all up here, but I was able to work it out by the examples. See, linear combinations of rational numbers are rational. Well, yeah, SPQ, I was wondering if you use irrational numbers, if you could somehow generate all of R under addition. But I don't think you can. Use Euclidean algorithm on 8 and 14? Does that come into play to figure out the group that they generate, or what will that do, Fembox? You're being serious? I can do it. Let's see. I really need to rotate this frickin' board. This section of it does not erase at all anymore. I need to figure out how to get this tray taken off, though. Okay, you want to use the Euclidean algorithm on 8 and 14, which we can do. The red marker is dying. 14 equals 8 times 1 plus 6. Shift over. Oops. 8 equals 6 times 1 plus 2. Shift over. 6 equals 2 times 3 plus 0. Which means the GCD is 2, right? That makes sense. Okay. I was just... So what's the interesting thing here? Here we go, he's using the whiteboard? Yeah. Just put new math on top of old math? Yeah, you're right, Phobos. Just keep writing on it. So now you know that 2 has to be in the group generated by 14 and 8. Yeah, because we can make a linear combination of them. Well, Z20 is addition mod 20, right? Oh, yeah, no, regardless, never mind. Okay, yeah. Oh, wrong browser. And so if 2 is in the group generated by 14 and 8, then it must include every number generated by 2, so every even number. Oh, is that the trick? Okay, nice. Thank you for sharing that. Oh, I didn't even notice that they had that at the right side there as well. What's the fastest way to multiply? A calculator. But the real answer is there's like mental math tricks, Steely. Gosh, you mentioned that you're a programmer, so you might mean it in a different sense, which underscore might be talking about. I'm trying to figure out the fastest way to multiply, like in the context of computer programming, or like how to do mental math tricks. All right, so think we're okay enough with that concept for now until we get to the actual questions. We do have the center of a group, which is you take only the elements that commute with all other elements. And so there's a little wording issue in this for me where even though it commutes with all other elements in G, that doesn't mean all elements of G are in that center group. But you will know that that center does commute because everything in there commutes with everything else, including the other things in the center. But all the things that don't commute aren't in there still. The center of a G is a subgroup of G. The centralizer, we're nearly at the end of the actual text part of the chapter, and then we'll get into the actual problems. Let A be a fixed element of a group G, the centralizer. Are all the elements that commute with A. So in this case, it may not commute with everything, but it will commute with some things, and so we just worry about those some things. And at the very least, we have the inverse in the identity included in this. Oh wait, yeah, yeah, because by definition, the inverse in the identity should commute. For each A in group G, the centralizer of A is a subgroup of G. Okay. All right, so maybe. Oh, about irrational numbers, SPQ? It's like you could name the subgroup generated by all irrational numbers is R. Okay, fair. I was thinking of a finite list, I guess, which I didn't actually say. But in my head, I was thinking of like a finite list of irrational and rational numbers, which I think because of Cantor's diagonalization, you probably couldn't do. But if you can take infinitely many irrational numbers, then that seems like it would work to me. Centralizer of a group answers the question, what's the biggest subgroup of G which commutes, in which A commutes with everyone in that subgroup? Okay. Prove that you need to show that it contains any rational number, let R be rational, and for example, R plus E is irrational, minus E is irrational, so R... Huh. Oh, yeah. Okay, that's a nice way of saying it, SPQ. Yeah, I guess our irrational numbers are too funky to be generated with linear combinations. Rational numbers, I'm sure you could generate with the finite list, right? Should we maybe go down the list for the first few questions here, and then we'll start skipping? So we work on like the basic concepts first. Oh, you couldn't... Key was not finitely generated? Really? Oh, oh, you might be right. So you need like every prime number or something, I guess, right? Maybe not even then. No, yeah, you could take, yeah, you need linear combinations of every prime, I guess. Okay. Yeah, you might be right. All right, see, I think this first one will be a good one to probably go through and actually do, and it looks like a little bit of a pain. I want to show the ink. Do I actually have ink for my red marker? Let me go check. I'm gonna order more ink off Amazon soon, but I haven't done it yet. That's green. It's orange. That's red. I think the green one's still holding out for now. But the red one is kind of dying on me. Come on. Okay. How does this work again? Oh, I need scissors? Ugh, I should have done this off stream. Okay. I'm smart. I'm sure I can handle this ink replacement in a timely manner. Okay, hold it with the tip up. Not the first time I've done that. Carefully remove the cartridge. And there we go. Cartridge removed. Then firmly push the new one in place. Pushed in place. Place the cap, and we're good. Okay. Parkour. All right, let's see what SPQ is saying. R1 over Q1 dot Rn over Qn equals all rational to the form. Yeah. I did realize that you never reach like other prime numbers, so I don't think at least. Let G be subgroup of R with addition. Either there exists an integer k in R such that G equals kz, or G is dense in R. Oh, so if you're working with real numbers under addition, either you're only the integers or some subset of the integers, or you have all R, or at least you have to include like all irrational numbers in an interval at least. Or yeah, or maybe rationals. It's 1/2 Z. Oh, never mind. Yeah, K can be anything. It's not just an integer. Well, if K can be anything, though, then I don't get what this is saying. You're either all multiples of a real number, or you're everything. See, I guess I was getting it mixed up with You're either a copy of Z or you're nearly everywhere. Okay. And so you can't have a subgroup necessarily. If you have a subgroup that's just an interval of R, you could do, no, you wouldn't be closed. Like if you're like if you want to say your subgroup is the real numbers from 0 to 100, you don't have inverses because you need negative numbers. If you say your subgroup is negative 100 to 100, well, even in the other example, you're not closed because you can do 100 plus 100 is 200. So is there a case, like, what's the nearly everywhere? Like, what are you able to miss and still be a subgroup? Q? Oh. Oh, because if you're... Oh gosh, that hurts my head. If you're gonna miss only Q, wouldn't you need every irrational number in your generator? Critical, that's a good question. Let's go do that quick. For P series versus geometric, it depends on where your n is. If n is in the denominator, you have a P series. If n is in the exponent, you have a geometric series. And I'll actually show you what I mean by that. Okay, try out new and improved red marker. So a P series is of the form one, oh, look at how much better that is. 1 over n to the P, where P is any number. Geometric series is of the form, I guess we can say, that's kind of bad. That's fine. A0 times R to the n. The difference here is where your n is. Here, like, this isn't geometric because you have a variable like in your rate. That's not a good way of explaining it, but if your n is out here as an exponent, it's geometric. If your n is down mixed in with a fraction, it's a P series. And if you have an n in the fraction and in the exponent, then it's something crazy. It might be E or I don't know, but you have to like do some weird comparison or something, or a root test or something. But yeah, a P series has n mixed in with a fraction to a constant power. A geometric series has a constant to the power of n. And then if you mix them together, you get something else entirely. Q square root 2. Yeah, I end up not following that. It might not be like, I might not have enough background to get that part, but no worries. Critical. Let's work on this more basic one that is my speed. Okay, so we want Good set of tools to tackle those without troubles is field theory. All right, I think it's more than a few chapters, but yeah. It's like the last third of the book, I think. Like the first third is group theory, second third is ring, and then the third one is field, I want to say. I don't know the table of contents in a minute. What version do you see between the orders? Actually, I should look at the table. So we have Z12, U10. U12, U20. In D4? Okay. This is going to be a lot of writing. I don't know if I'm going to do it for all of these, but let's at least go through some of them. So you want the order of the group and the order of each of the elements. So I would say the order of Z12 is... So if we're talking addition mod 12, I think we're just 12, because we have 0 through 11. Oh my god, that's going to be so much writing. The order of 0 is 1. The order of 1 is 12. The order of 2 is 6. The order of 3 is 4. The order of 4 is 3. The order of 5 is a bit more challenging. Is it going to be like their LCM or GCD or something? Addition mod 12, we want to get to 0. So it's going to be their LCM? 60? Which is 5 times 12? Okay. I'll buy it. Because it saves me work. 2. 5 and 12 are relatively prime. Maybe that's the key. Wait, is the LCM divided by GCD or something? It's like here with 7 we're getting the same issue, right? Because 14, 21, 28, 35, 42, 49. Yes, it's only 7 times 12, isn't it? Or that's just their LCM, rather. Oh yeah, never mind. Their GCD is 1. 72? No. Wait, 7 times 12. That's 84. There we go. Wrong multiple choice. Eight and 12. 24 is 3. 9 and 12. 36, I want to say. 4. 10 and 12. 60. 11 and 12. What's the trick with 11? It's like 1, 3, 2. It's like the GCD for 418 and Z20. You can do it manually, kind of in groups, but the good set of tools to make things more natural is ring theory. So I mean, you wouldn't tackle these tools you currently have. That's good training. That means you shouldn't. Oh, okay. Yeah, I figure it's so foundational. We should understand how to do it the hard way before we get the easy way. So is this all the LCM divided by GCD? What is that? Oh, that's 4. The LCM of 3 and 12 is 12. The GCD is 3, so that works. Yeah, you know, proof by looking at one example is good enough for me. LCM over GCD is what I'd say the pattern is there. Does that apply to 0? We should probably check that. The LCM of 0 and 12, is that 0? That doesn't make sense. Maybe for 0 it doesn't apply. The numbers you wrote there look a bit sketchy. Oh, really? $5? Oh, did I mess up? It's 7 plus 7 plus 7. No? This one looks sketchy. I assume it's gonna be like 7 and 11. But how else do you get to 0 when you mod 12 if it's not a multiple 12? They do seem like high numbers. Well, what did I do wrong then? So you have to do 11 plus 11 is 22, plus 11 is 33, plus 11 is 44, 55, 66, 77, 88, 89. Am I missing something? Addition mod 12. Oh wait, I'm writing the actual number. It's 11 times 12. So the order of 11 is 12. There we go. I had the right idea, it was just the actual number that I wrote. I was writing the result of the multiplication, not the thing multiplying by, which is what the order is. I forgot, what was it for 7? 84, which is 12? Okay, never mind. I was thinking the yeah. Look at the orders of these elements and compare with the orders of Z12. If you look at all the orders of these elements, compare it with the orders of Z12, is there something in common? All of these divide 12? They're all factors of 12, I guess? Okay, awesome. So is there something with the GCD in LCM? Could it be LCM over GCD? No, it can't. I don't know if we can get a clean formula like I was thinking that we could, but and I think it's very worth noting is look at all the orders you came up and then look at them in backwards order. Look at them in backwards order. 12, 6, 4, 3, 12, 2, 12, like that backwards order? Wait, 12, 6, 4, 3, 12, 2, 12, 6, 4, 3, 12, 2. It's like a palindrome? If we exclude the identity. That makes sense with how it cycles around, I guess, that it's like symmetric in that way, where B's match B's and 2 is in the center, which might be a dangerous word to use here. Sure is? Okay. I mean, I guess that has to do with how maybe inverses, like what are inverses here? Like 9 and 3 are inverses, they have the same order. 10 and 2 are inverses, they have the same order. That's probably why. 5 and 7, okay. Interesting. U10 is 1, 3, 7, 9. Order of 1 is 1. Order of 3. That's why it works? Okay. So we have 9, 27, 81, 243. Oh, wait, no, we're modding 10 each time, though. I shouldn't go off the rails like that, right? 9 mod 10 is 9. 27 mod 10 is 7. 7 times 3 is 21, mod 10 is 1. Wait. Oh yeah, 1. Okay. So wait, I wasn't keeping track of how many that was, though. 3 times 3 is 9. Times 3 is 27, is 7. 7 times 3 is 21. So 3 is order 4. And if 3 and 7 are inverses, I'm just going to say that 7 is order 4. No, it's order... no, yeah. Probably. I don't want to... Okay, let's do it. 7 squared is 49. Mod 10 is 9. 7 times 9 is 63. Mod 10 is 3. And then, okay, yeah, inverses. 9... That's going to be self-inverse, right? It's going to be squared, because 81 is 1 mod 10. Okay. That'll be a nice trick to save some work and make this not as many calculations as it seems. U12. We've got 1, 5, 7, 9, no, 8 as well. No, wait, relatively prime? Never mind, so not 9. 11, and then we're done. I think so. Okay, so 5, 25. Oh, you're self-inverse. 7, 49. Mod 12. Well, 12 goes into 48. Really? 121. Wow. It's weird. So all these elements are self-inverse, I guess? We have next U20. Not 4, not 5, not 6. Yes, 7. Not 8. Yes, 9. Not 10. Yes, 11. Not 12. Yes, 13. Not 14. Not 15. Not 16. Yes, 17. Not 18. Yes, 19. Okay. 6, 7, 8. Um... 9, 27 becomes 7. Wait, 9, 27 becomes 7, another 3, and then you're home. 4. The order of 7. Isn't it funny you found the groups of order 4 which don't have the same structure? Depends how you define fun, but it does seem like it, yeah. This one's gonna have twice the order of the other one, so maybe there'll be some. Maybe we can realize this is some combination of the two somehow. I don't know. What's the order of 7? 49 becomes 9. 9 times 7 is 63, becomes 3. Oh god, I keep forgetting to count the 7s as I go. 7 times 7 is 9. Times 7 again, that's 4. Yeah, wait. 49 becomes 9, becomes 63, becomes 3, times 7 again becomes 21 is 1. Okay. Squared, right? Because 81, 20 goes into 81. As 11 our halfway point, we have, yeah, 11 is the halfway point. Okay. 22. No, it's not 22. 121, so you're self-inverse. So I'm going to expect this one to be 2, right? No. 13 squared is 169, which is 9. It's going to be easier if you do the trick and you do -7 to powers. Leading question could be, could there be more structures for groups of order 4? The answer is in the next chapters. I'd imagine you only have so many possibilities if your orders of the elements have to be factors of the overall order. So like for order 4, I wouldn't think so. Because you need symmetry and you can only choose between 1, 2, and 4. So I can't imagine, at least for this instance, that there would be. Why don't 9 and 13 have the same order? Didn't we say that? I did do 9 right? Yeah. Is it going to be order 4? Oh, I guess because the symmetry is with... I think at 13 is equal to -7 mod 20. So I'm just using the answer from 7. I don't know if that's a good idea. No, it's probably not. Because -7 times -7 is positive 49, becomes 9, times -7 again is -63, which isn't the same mod 20. It's 17. Ugh, but 13 is such a pain. I really like how you think. I mean, I'm just kind of guessing here. Series here aren't symmetric about the center like they were in C12. Okay. Well, thank you though, underscore. All right, let's just 13 mod 20 is equal to -7 mod 20. And then we take powers of -7 mod 20. It's 9. Nine times -7 mod 20 is -63 becomes 17. That 17 is where I was like, ugh. And like, I'm not sure if I'm doing something wrong now. 17 times 7. Get a 9. Is that 119 negative? Which becomes 1. It is 4. No, it's 3? No. Can't be 3. The options are 1, 2, or 4, right? So, yeah, we have, okay, it's 4. And 17 is the same as negative 3. So negative 3 times negative 3 is 9. It's still 9. 9 times negative 3 is negative 27. Is 13. 13 times negative 3 is negative 39. So we're order 4. Okay, and 19. Oh my god. That's oh wait, no, that's self-inverse. Because it's equal to negative 1 mod 20. Okay, so what can we say about U20 here? We don't have quite the same symmetry here, do we? I don't really have any symmetry, to be honest. We got 4, 4, 2 and 4, 4, 2 joined by another 2. Okay, what the hell? The order of 3, 7, and 9 match the order of 3, 7, and 9 here because 10 and 20 are multiples of each other. Whereas it's not true from U12. I mean, or if it is true, it's by coincidence, I imagine. I don't know if we can make any similar statements about, I guess 13, 17, and 19 could be related to 3, 7, and 9 in some way. I'm not sure though. U17 equals, oh, you're right, Fembox. I forget that I can do that. Like, I forget like the extent of how much you can use that trick. So I remember to do it to the one number, but not the other. Thank you for reminding me of that. Okay. So I assume the realization is that we have U10 is basically the beginning to U20. And then we still have to do D4 as our last one. Which is the dihedral group of order 8. Which, I guess the dihedral group of order 8 gives us a hint about the order of the group. So we have R0 is 1, R90 is 4, R180 is 2, R270 is 4. We have a vertical flip, which is 2, horizontal flip, which is 2, diagonal flip should be 2, and an off-diagonal flip of 2. I think all the flips are self-inverse. So this is, I guess, just showing an example of a same order, different structure. We're gonna look at the Cayley table for this one though. I don't feel like doing that much mental visualization right now for the square. D4 is correct? Okay. We're trying to see between the orders of the elements of a group and the order of the group. Well, I guess we kind of discussed that earlier on with the exam, so I don't know if there's anything more that we can say about this. But I feel like we have some good discussion with it, so maybe we can move on. Let Q be the group of rational numbers under addition, let Q star be the group of non-zero rational numbers under multiplication. And Q lists the elements generated by 1/2. Oh yeah, I remember seeing Penn Center do this one, and I think I made the same mistake that he did when I first saw this problem. So the elements generated by 1/2 under addition are basically all multiples of 1/2, all integer multiples of 1/2. Can you get to 0 from... Oh, you must be able to get to 0. Yes. Because under addition, 1/2 to the 0 is defined to be 0, the identity. So I would say for number 2 here that in Q, the elements for the group generated by 1/2 are 0, 1/2, 2, 3/2, 2, 5/2, etc. And also -1/2, -1, -3/2, and so on in that direction too. For Q star, it's going to be all powers of 2, positive and negative. Which I guess I should be specific about powers since this is abstract algebra. The identity is 1. You go 1, 1/2, 1/4, 1/8, 1/16, and so on like that. And then in the other direction, you go 1, 2, 4, 8, 16 in that direction. Okay. And then find the order of each element in Q and in Q star. The order of the identity is 1. I think the order of every other element is infinite because these aren't really cycling. If you have 1/2 and you keep adding 1/2 to it, you're never going to get back to 0. If you have -1/2, you keep adding -1/2, you never get back to 0. And with Q star, if you keep multiplying by 2 or keep multiplying by 1/2, you're never going to get back to 1. So the identity is order 1, everything else is infinite order. Prove that in any group, an element and its inverse have the same order. This is probably a good one to try. I assume we're gonna let, like, you know, A have order n and A inverse have order n and try and do some magic there. let A belong to G. The order of A equals M. The order of A inverse equals N. Okay. So, I guess we know A times A inverse is E. We know that A to the M is E. We know that A to the N is E. And we somehow want to get to M equals N. We're about to say, but you need to wake up early. All right, underscore. Well, thanks so much for hanging out. I should give you a save. At least one for all the help that you've given. And yeah, hope you have a good night and that you sleep well. So if A to the M equals E and A to the N equals E, we could look at, oh wait, I'm sorry. A inverse. We could multiply these two together and this still equal E. We also know that A inverse N is A to the negative N. My playlist just cycle back around on itself. Much like this playlist is a cyclic group, it seems. And that doesn't make sense, but let's get a different playlist in here. Okay. So now A to the M minus N is E. Does this mean that M minus N must equal 0, or is there some other possibility? M minus N is the order of A? Hey, this can only be true. Can it? I think I just need to interpret this last statement here right, and this is the proof. Does this necessarily mean that M equals N because A to the 0 equals E? I mean, we also know A to the M equals E. So, okay, maybe since A to the M minus N equals E, either M minus N equals 0, which implies, actually, no, let's not, well, either M minus N equals 0, or M minus N equals, theoretically, K times M, where K is some integer, right? Because if A is order M, you could also have A squared to the M, and that should still be E, I think. I don't know if I'm being too careful with that, but positive. Maybe that's weird. It'd be a lot easier if I can say just M there, and let's just do that. It'll make the proof easier. I don't know if it's technically right. Oh yeah, M is defined to be the lowest power such that this is true, right? Yeah, it wouldn't be a multiple of M. That makes no sense. Implies N equals 0, which cannot be true because A inverse cannot have 0 or order 0. I think that's our... It must be that m minus n is 0, so m equals n. I think that's it. Oh, it's an even number, so I only able to tell how the book intends it, but proof makes sense to me at least. Do I have to worry about, Yo, Waffle, how's it going? Do I have to worry about n being greater than m? I don't think so. Yeah, I think we're good. Another lovely Tuesday, exactly. It's going good for me too. I had some fun questions from chat earlier. Things have slowed down now, so I'm just kind of chilling and doing some algebra-like studying to fill in the time. Whoa. And for those who didn't know, Waffle also streams math. You should go check him out. No worries. So number 5, without actually computing the orders, explain why the two elements must have the same. Without actually computing the orders, explain why the two elements from Z30, oh, they're inverses. 2 and 8 are inverses, 7 and 13. Are those inverses? They probably are. Seven times 13. What is 7 times? I can be smart about this. We can say it's 7 times negative 2, which is negative 14, which is 1. Yeah, so 7 and 13 are inverses. Okay. Find the order of A, the order of B, and the order of A plus B. All right, it's probably a good exercise to do here. 6. I'll put it over there. Let me actually take that part off. Okay. Oh God, I should spray this thing. Okay. Super. So we're interested in the order of A, the order of B, the order of A plus B, and we're working with integers mod what? 12? Okay. So start off with A equals 6, B equals 2. The order of A is 2. The order of B is 6. The order of A plus B is, well, 6 plus 2 is 8. 8 plus 8 is 16 is 4. So 3 is the order of A plus B. Okay. Then we have A equals 3, B equals 8. Order of A is 4. The order of B, we already got, yeah, it's 3. The order of A plus B is 11. 11 plus 11 is 22, is 2 mod 12. Okay, wait, okay, 11 plus 11 is 2 mod 12. 2 plus 11 is 1 mod 12. 1 plus 11 is 12. Okay, so A plus B is order 4. Then A equals 5, B equals 4. The order of 5, 10, 15 becomes 3, 8, 13 becomes 1. This makes no sense to me. It's going to be some really big order. Oh, it's going to be 12, isn't it? Yeah, it's going to be 12. Okay. The order of B is 3. Order of A, it's 9. So 9 and 12 share a factor, so it's not going to be 9 times 12. What? Hey, Anders. 9 plus 9 is 18, becomes 6. 9 plus 6 is 15, becomes 3. 3 plus 9 is 12. Okay, 4. I remember seeing Vincent do this one, and it looks like there may be some kind of relationship here, but it's not really easy to tell. So it might also be nothing. But I don't know. I don't really see anything for myself here. The thingies. Yeah. Okay. If A, B, and C are group elements, order of A is 6, order of B is 7, I'm fine without that problem. Can you say what a subgroup D3 that contains R240 and a reflection F? So D3 has to do with triangles, right? And your rotations are 0, 120, and 240. And you have 3 different reflections that you could possibly choose from. So if you have one rotation, you have all the rotations. Well, one non-identity rotation, I guess. If you only have one reflection, though, I think you can't make the other reflection. Or maybe if you rotate it. No, yeah, you can rotate it and then reflect, right? See, you can actually, yeah, that it's just equal to D3, I want to say. See about a subgroup of D3 that contains 2 reflections. Ooh. I'd have to draw that one out. Can you make rotations using 2 reflections? I feel like you probably could. All right, so let's say we have an equilateral triangle. We'll say A, B, and C. If we're only allowed 2 reflections, let's arbitrarily say you can have a reflection like that through the top, or a reflection like that through the left side. And let's see if we can achieve A, the third reflection, and B, a rotation. So let's try doing TL. That's probably not the way it's normally defined for D3, but who cares? So TL means that we reflected B and C. And then we reflect. So B would be over here, but then it comes up. C is over here, A is right there. And what would be the result of that third? Just A and B are switched. Huh. If we did another T, what would happen here? B, A, C. Oh, hey, this achieves the third reflection there. Okay, so with 2 reflections, we can get to the third. Now, can we make a rotation? Is this a rotation already? No, it's not. We can make it a rotation, though, if we do TLT, or if we can, like, TLT squared would be a rotation, but is there a simpler one? Or would TLT squared be a rotation? What is LTL, maybe? Switch A and C, and then switch B and A. B, C. Wait. Yes. Wait. No. You do that, you switch A and C. Then you do a top. Wait. Okay. I'm not visualizing this right. You would switch, so C goes on top. Okay, C stays on top. And then A goes down here and B goes there. That's a 120 rotation, isn't it? Okay. And if we can make a rotation, we can make any rotation we want. Okay. So if we have 2 reflections, we can make the entire D3 group. God, that visualization is hard. Okay, which ones did Pen Center like call out here? All right, the one Pen Center called out. Oh wait, 13 through 15. Let's work on those. For any group elements A and X, prove that the order of XAX inverse is equal to the order of A. Okay. Oh wait, that was also a reflection. I just realized that TL was a reflection. Oh well. Okay. For any group elements A and X, prove that XAX inverse is equal to A inverse, or A. Okay. Well, let's name what their orders are, and then say that means A to the M equals E, and that XAX inverse to the N equals E. So we can set up, I guess let's maybe expand this thing out first. Equals XAX inverse, XAX inverse, dot, 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 XAX inverse. X inverse times X, X inverse times X, and so on, so we get X, A to the N, X inverse. Because all the X inverses in the middle cancel out, and the A's collapse into A to the N. This still equals E. Oh. And I think that's going to be important. Because we can left multiply by X inverse. And we can right multiply by X. Which means A to the N equals E. Does this necessarily mean that N equals M though? Could N be a multiple of M? I don't think we know that, do we? Hmm. This is weird. I don't know exactly how you make this last conclusion here. My worry is that if you know a squared equals e, that means a to the fourth also equals e. So how do we know that we don't have this situation with n and m? Like, how can we prove that we don't? The order of x inverse. Yeah, it must have to do with the definition of order here, right? It can't be that high of a number, but I mean, it can be, I don't know. This is an odd number problem. Yeah, it's 13. Nobody's saying this, how can we show that n is the least integer such that a to the n equals e? Hmm. Oh, SPQ, I didn't even say that. All right, sorry if you read the log when I missed it. You can show that x inverse to the n equals e if and only if a to the n equals e. Does that help though? I don't see how that helps. I'm basically concerned that I'm not disproving that n isn't a multiple of m. And if that does address that situation, like, you know, n isn't necessarily the least integer such that a to the n equals e. It could be a greater integer. Like, that's the part that I'm trying to figure out. And I don't see how that necessarily helps, unless I'm missing something. Recall the definition of order. 13 falls immediately from that. Maybe let's look at the definition of order then. So I know that minimal positive elements in both sets is the same. So yeah, I guess trying to bridge the gap from n being the minimal element for xa x inverse to also be the minimal element for a. Right? We're saying that they're the same set. I guess is fair because you're not actually changing what's in the set with the x inverse business, are we? You know, that's what we just showed. I guess so. Yeah. I agree with that definition. The order of x inverse equals the minimum, right? So okay, I'm looking at those two equal signs in the middle there and trying to justify that. It's the minimum n in positive integers such that xa x inverse to the n equals e must be the same minimum so that a to the n equals e. And I guess it makes sense if they're really the same set. So they should have the same minimum. Okay. I'm kind of curious how the book intends it, but I think I can buy that argument. Yeah, if they're really the same set, or you know, they include all the same elements, they should have the same minimum. I feel like that doesn't address my question, what the book did. What's exercise 27 of chapter 2? Okay, this is chapter 2. Oh. Not that helpful. Homomorphisms? No, not yet. Oh yeah, that's right. I want to look at the table of contents. See where it's going. I should really just use this page number thing. So we're on chapter 3. Going to cyclic groups, permutation groups, isomorphisms, cosets in Lagrange's theorem, external direct products, normal subgroups, and factor groups. Homomorphisms until chapter 10. All right. into rings, then fields, so much further. Yeah, at the pace I'm going, it's gonna be a while. Yes, critical. That's a P series with, since n squared, P is greater than 1. So you'd say that converges. The decision of the author to delay homomorphisms that far away. Yeah, I remember you saying that when this book was first like brought up. It seems like they're hinting at it, but we got a lot of permutation groups. Just sounds annoying, I'm gonna be honest. I don't know what a coset or a Lagrange's theorem is, but maybe those will be interesting. It's not that bad? Okay. Yeah, I feel like for these, I kind of just want to like get through them, because isomorphism is probably going to be like a much bigger topic. But no, we'll find out. All right, so 14. Prove that if A is the only element of order 2 in the group, then A lies in the center of that group. This falls from the last statement, right? Lagrange is just that the order of the subgroups always divide the order of the... Oh, okay, and we've already kind of discovered that naturally. No, yeah, when we're doing this first problem up here, we kind of like observe that in these examples. No problem. Critical. Is that A to the n equals E if and only if B to the n equals E. Oh, suppose that A to the n equals E if and only if B to the n equals E. With law of generality, let the order of A be less than the order of B, then B to the order of A equals E. Supposing you have two elements of the same order. Well, yeah, I mean, I guess my issue was that B was like a compound, I guess. Like it was expressed like, you know, it wasn't just B, it was XA X inverse. And I guess I was wondering if in the process of getting rid of the X and the X inverse, if you're changing the order. It doesn't seem like you are. But that's the part that I was trying to like reconcile. So like if it's just B there, I guess I can see that. But like we changed what B is along the way. In reality, it's a bit more general because it also says something about infinite order. Oh, okay. Fair enough. So yeah, I might just be being like picky with showing that n is like the least, but well, XA, X. But we changed the B, that's the issue. even if you want to make it xa, we end up with a to the, oh. Actually, I started out with different, oh my gosh, I might just be being, like, I might just be being like a contrarian, but like, we don't necessarily know they have the same order. We're trying to prove they have the same order. So I simply said the order of A is n in the order of xa, xn versus n. But I don't know. If I'm just being difficult, I can accept that too. I'm just rereading your thing again a few times now. I don't know. I'm just have to think about how that applies to the problem, because I'm still not exactly seeing it, but I'm sure it does, and I'm just not making the connection. But I assume that shoot, I had an idea for 14 that I now forgot. I was gonna say we should use 13. Why would that be? I was about to do I mean, so SPQ and I have been discussing 13, Anders. My proof for 13 is actually still on the board. I was getting concerned that we don't know, in my very last line, we don't know that n is the least number such that a to the n equals e. So we don't, I felt like, I still kind of feel like I haven't necessarily shown that in that last line that n is the order of a, and so n must equal m. And so SPQ was giving some like justification that I'm sure works, but I haven't been able to wrap my head around yet. Well, I guess I still like the argument SPQ says that arguing that the sets are equal to each other, and so they should have the same minimum. That one I'm on board with. The more recent thing I'm still not sure about. For finite order, yeah. And so yeah, I was about to move on to 14 because I don't want to argue about the same problem like for forever. Just I'm sure it's just me being obtuse. For infinite, you can just take the minimum doesn't exist. That's fair. Oh, so that's why you're saying your other like way of saying it. Okay. If A is the only element of order 2, then A lies in the center of the group. Maybe we don't use the last one for this. If A is the only element of order 2 in a group, then A lies in the center of a group. So A should commute. Oh, maybe we. Ooh, it's maybe the same idea, but not this exact. We don't care about the order as much. A is the only element of order 2 in a group, then A lies in the center. So we need to show that A commutes with everything. I think the idea that I was thinking for this one, I don't think is quite right. You thought question 14 was one of the hardest ones? Oh, is this the one that Suki found that solution to? I wasn't paying enough attention during that part of the reading group. I have like a 1% idea of what we can do. I'll just try playing around with it and seeing how far we can get. You think it was Suki? Okay. Let's rephrase the question. Prove that AX equals XA for all X in G. That's a 6. Because that's what it means to be in the center of a group. Oh, you think about contradiction, Anders? That could be good. I was thinking that the order of A being 2 implies that A squared equals E, which implies that A is self-inverse, and that we can do some funky solving with that to try and prove commutativity. So I belong to G. And AX equals Y. So I was thinking like we can set up something like this and hope that we can do some weird multiplying stuff to get to xa equals y. So x would be like a inverse y. But we need to really right multiply something, don't we? This might not be the technique. And can you do anything sneaky if you say that E is equal to A times A inverse? If we just figure out a way to get rid of the A's now, that'd be great. Or the A's on this side. I don't know if you really can, though. So maybe contradiction is better. Well, we could construct another element of order 2 if we do B inverse, if we rely on exercise 13. Let's try going down that path, since my path didn't work out. Suppose that A is order 2. Oh, what's up? Remember that A is inverse of itself? Yeah. So maybe we don't want to do BA inverse B, or... Oh, I might see what you're saying. Maybe. We can do like ABA and then something good happens. Let's start writing things down. Hopefully it comes to us. Then there exists a B belongs to G such that AB does not equal BA. Okay, so the order of A equals 2 implies that A squared equals E, implies that A is self-inverse. So do we want to examine well, we can't use exercise 13 in the way, if I do use exercise 13, we have to have A in the middle. I don't know if that's what we want. So I might need to forget about exercise 13 entirely. Because I think Andrews is saying that we should look more at something like ABA. So maybe we could set up ABA equals ABA, something that is self-evidently true, and then do some inverse magic. So I can say that A is the same as A inverse. BAB inverse? Really? Okay. I just realized that this thing isn't what I hoped it would be either. What to do with BAB? Or wait, isn't that what I was saying? BAB. Beep boop. I said ABA inverse? I did? I don't know what I said. What language is this? It's robot, apparently. Phobos. I don't know. So wait, Andrew, do you want to look at BAB inverse squared? I guess. Can you somehow get to it equaling E? What does that do for us? Oh, because this also has order 2. So we're still using exercise 13 here. Okay. So I think before I even think about that, let B belong to G. Oh, wait. Okay. Then the order of B is equal to the order of AB. No, you said BAB. Dang it. Okay. Then the order of A is equal to the order of BAB inverse by exercise 13. Okay. And this is why we look at squared. I'm still not sure where this is going. That BAB inverse is equal to E. No, if this equals E, who cares? What does that do for us? A equals XA X inverse, they are equal. Or in your case, A equals BAB inverse. Find another element of order 2, which contradicts that A is the only one. So AB equals BA. So we don't necessarily have to. Okay, yeah, so if we both. Huh, okay. So we don't necessarily have, if we follow Zone Ranger's train of thought, this doesn't necessarily have to be proof by contradiction. Oh god. A Is B a B inverse? There's only one element of order 2. Oh, I guess that's a really simple thing. Okay, so if I don't want to lose the work up here, but let's just like, if we restart the proof just from let B belong to G. By exercise 13, the order of A is equal to the order of B inverse, which equals 2. But since A is the only element of order 2, it must be that A equals B inverse. And then we right multiply each side by B. Okay, that's a really nice way of doing it. That's a stupid way of formatting this, but wait, I can't write. Wait. Yeah, I switched that in my head. Goodbye, eraser. Oi. Therefore, A is in the center of G. Interesting. There's one more detail which we can skip or not depending how rigorous. I guess hit me with it. Thank you for the help there, Zone. Okay, let me get back to your whole chain of equal signs here. Oh, right. So we would need to see what happens if it's order 1, or if it's equal. I mean, that'd be equal to the identity. Or B is the identity, right? But I thought we were saying that. Oh, okay. I was like, I thought, aren't we saying in that proof by contradiction? Aren't we saying that? You know. Yeah, it should be order 2. So actually, with the proof by contradiction, Anders, are we still supposing that A is the only element of order 2? Or I guess we're showing that it's not. We would suppose it's the only element, and we show there's a second one. Does that necessarily mean it's in the center? I guess I'm not really. The more I think about it, the less I'm following your proof, to be honest, which is probably my own fault, but Waffle, these are from an abstract algebra textbook that Penn Center is doing a reading group on. I'm on page 92. So it's from this textbook here, which there's a PDF in Penn Center's Discord. If you're interested, you can just like DM Penn Center and he'll add you to the like channel in his Discord. So yeah, it's just been like something I've been studying out of just kind of to follow along with the group and just learn out some abstract algebra, I guess. Maybe beyond your skill scope. That's fair. They're not too deep into it yet, but I would definitely, if you do it, I'd spend like I spent a good bit of time with the is like chapter 0 for the preliminaries. I spent a good amount of time just looking at all this stuff here. It kind of gives like a crash course on getting up to speed with what you need going into the book. It's not perfect, but I haven't run into that many issues after like putting in some work with the foundational stuff here. And of course, it's like a no obligation thing, so you could just like ask to be added and then never do anything again if you didn't want. But okay. Accessible intro book and abstract algebra. Oh, interesting. Oh yeah, sure. Waffle. Let me bring it up again. It's also just like an actual like PDF of it posted in the channel for the reading group as well. But I'll show it here too if you want to find it for yourself. Yeah. Then BA, if the order of BA, B inverse is 1, then A equals 1, which is a contradiction. Okay. No worries. 92. So so many good math texts to read so little time. Yeah, Fembox, I feel that. I have a calculus book that I'm trying to read a little bit too, but it's hard to like study that many things at once. So many books stacked up. So, Andrew, I guess I'm confused on what like your proof does, because we're supposing that it's not in the center. And did we ever show that it's not in the center? Like, I feel like we only contradicted the order part. Switch over the questions take 5 years to answer. Yeah. Oh my god, I feel that too. This is the last time I streamed like doing this like me working through some problems here. There's a problem in question 2 that I tried to prove that like almost no one in chat liked, but it made sense to me at least. So it was probably like a good like hour that we're just going back and forth about it. But okay, let's give out some saves. Anders. Also for SPQ, I should have gotten you a save for the stuff earlier. If B does not commute with A, then BAB inverse is not equal to E. Wait, if it doesn't commute, that means that BAB inverse isn't E? Why is that? I know that BAB inverse wouldn't be equal to A. Oh, because that would imply that's order 1. Okay. Yeah. Okay, fair, SPQ, yeah. Then B and A would commute, yeah. Right. And the second part you said after the but is BAB inverse squared equals BA squared B inverse equals E. Which does imply that it commutes, is what we're saying. BA squared B inverse equals E. Does that somehow contradict the first statement? Oh, it would imply the only element of order. Oh, okay. Fair. And so that's our contradiction. Okay. So yeah, I guess that's what we do if we do want to go down the by contradiction route. Give you another save for that. Yeah, I like that. So the we have 15 is something that Penn Center called out to do. Prove that no group is the union of two proper subgroups. Does the statement remain true if 2 is replaced by 3? This one seems like a challenge problem. No group is the union of two proper subgroups. So this one definitely makes me think that you would want to do a proof by contradiction, and suppose there are two groups that union to, or two proper subgroups that union to the entire group and show something bad happens. What would that be though? I I I I get the feeling that we'd want to look at generators. I don't know, like, how can we engineer a situation? Like, we need to look at something that both of these proper subgroups have necessarily left out. Should we start by looking at small group sizes, maybe? Because, like, you have to have at least 3 elements here, right? Or I guess 2 elements. Well, they could be the same subgroup, I guess. But yeah, you need at least 2 elements to have a proper subgroup though, right? I can't think of a single group of 2 elements though. I don't know. Oh, you can't have an inverse unless it's self-inverse. But if it's self-inverse, doesn't that mean you only have the identity? So maybe you need 3 elements. No group is the union of 2 proper subgroups. I mean, it's not necessarily a contradiction, like, the way that I was thinking. I don't know, like... I can't imagine that, like, the center of a group is helpful. I'll show it again, Anders. No group is the union of 2 yes, that's how it's worded. Number 15 here. It's false? Oh no. I couldn't think of an example, or like, I was having a hard time thinking of an example, to be honest. Take any proper subgroup twice? Really? Wait, you don't do anything when you union them, though. How does that do it? Yeah. So that's to be a proper subgroup, so if you just take the same thing twice, then you have to be leaving something out, don't you? Okay. Oh, it was the like not proper part. No group is the union of 2 proper subgroups. Interpreting another thing? Okay, no worries. Let's at least write a setup to this down. Check and hint. This is basically equivalent to the statement that the union of 2 subgroups with non-empty symmetric difference is not a subgroup. Non-empty symmetric difference. What does symmetric difference mean? That you're including like all the inverses and things like that? Okay, no worries, SPQ. Dang it! This playlist looped back around. 1 second, after I do this. But A and B be subgroups of G, A and B subgroup of G if and only if they're not proper, only if one of them isn't a proper subset. I mean, I can see how that's like an equivalent statement, but I don't know how that makes it easier to prove. If you just blindly union two proper subgroups, like, do we even know that that's a group? Is the union of two groups another group? I feel like no. Because, like, what would you get if you union, like, integers mod 12 and a dihedral group of order 4? Like, two completely, to me, like, unrelated groups. I mean, okay, never mind. I mean, these are proper subgroups in G, though, so well, maybe subgroups of, I guess, is the question. So maybe that doesn't apply. If they're both subgroups, then maybe we can make the claim they are a group. They just aren't going to be G? Or... Dude, I gotta use the bathroom. I'm gonna be right back. Okay. Um, so you're saying that integers times 2 union integers times 3 is not a subgroup with addition because it's not closed with 5. Okay. If G equals A union B, A and B proper, then G minus A is non-empty. But G minus A is a subset of B, therefore B minus A is non-empty. Yeah, sure. Scientific. Happy to look at it. I mean, I feel like I was thinking that like you can pretty easily prove that you can't just take A twice, or you can't say that, you know, A equals B. And so if A doesn't equal B, wait, is it possible if you have two sets that you okay, yeah, no, never mind. All right, and if you know that A doesn't equal B, then like the B minus A and A minus B thing being non-empty would follow from that even? Um, maybe that A is a subset of B. Oh, okay. Well, A could be a subset of B in the problem, but you've shown that they aren't subsets. Well, I'm saying like, well, I guess I'm saying like from the wording of the question, I guess you can conclude that they must not be subsets, but the wording of the question doesn't imply that. Well, it does imply that. God dang it. I don't know. They didn't say it explicitly. Okay. Oh, that's fair. Okay. Let's try to figure out this limit first, though. Supposed to use squeeze theorem to get to 0. Um, multivariable cosine. Is it legal to take the argument of cosine? I think they'd be hard to compare. Because do I analyze using the squeeze theorem? If limit of the argument minus pi over 2 is equal to 0. Really? The limit of the argument minus pi over 2 is equal to 0. Well, the limit of the argument minus pi over 2 is 0. That means the argument is pi, right? Oh, no, never mind. I'm sorry. I don't know why I said that. It's pi. It would mean the argument is pi over 2. Sorry. And yeah, that's not necessarily squeeze theorem, I guess. Although, well, maybe you can engineer it so it's like that. I mean, so do we know that the inside would be greater than cosine of that thing? It'd be nice if we can prove that. I don't know how we prove that, though. Ooh. If we can show it's greater than 1, which might be possible. Okay, let's... and Yini, thanks for the follow. Okay, let's take a look at this. I think maybe we can boil the problem down to cosine x minus 1 over x squared plus y squared. Okay. So, I think what will be great here... Well, oh no, that doesn't make any sense. Huh. No, the idea I had is bad. The thing that can we figure out the like this limit just of the inside? Like that might give us a clue as to how the cosine is behaving close to 0. If cosine of that thing is approaching 0, I see what you mean with this would have to be like pi over 2 or 3 pi over 2 or some multiple. Which, that doesn't seem like it would be pi over 2 to me, right? Huh. You know what? This is a tricky one. Whoa. Is this like sine x over... Is this like sine of 1 over x, but fancy? Yeah. So Desmos can't really render it properly, but I think this is a multivariable version. I guess we can do of cosine of 1 over x. And it gets, well, yeah, I mean, it just gets like infinitely erratic around 0. Is this limit really going to be 0? Because this limit, it doesn't exist for cosine of 1 over x. I'm kind of surprised if this limit comes out to be 0. I'm going to be honest. It could. I don't mean... One should not exist. Okay, SPQ agrees. Wolfram Alpha agrees. Choose a path where x equals 0. Cosine minus 1 over y squared. But then you plug in 0 for y. So cosine of infinity, like what is that? Or negative infinity. Oh, just, it doesn't exist. And that's enough for you to say that. No, that's fair scientific. I think it's just wrong. I think this book is giving you an impossible task. No, you're completely fine. Because I was like, how would you do this? I wonder what they maybe meant to say. And if nothing else, like this graph looks kind of sick. Let's go deeper. Yeah, it's getting just more and more erratic. It's like a forest in here. Ugh. It's funny. I wonder how the book thinks that you can do that limit. Okay. So I guess unless you have anything else scientific, I'll go back to doing this algebra stuff. And SPQ earlier was saying that we know that A doesn't equal B. We know that A can't be a proper subset of B and B can't be a proper subset of A, which means their differences are non-empty. And so maybe we need to look at what's in their differences and multiply those together. No problem, Scientific. If you run into anything else, please let me know, though. Let's go. I have like part of an idea here, so let me. I think we can violate closure. With your idea here. Oh, and Nini, I see you're chatting. Just found you. Where have you been when you had your university exams? Oh no. Yeah, I've been here, but it's always a good day when we can bring someone new into the Twitch math community. If you're gonna have more math classes, like I'm sorry that's too late for your exams, but if you're gonna have more math classes, or you just want to talk about or see math be done, there's a whole bunch of other math streamers out there too. But yeah, welcome in. There's many more streamers than that too, but those are ones that I like can recommend the highest, who I know the best. It's like we're going to directly contradict the closure. So my idea was... Really? Okay. I was thinking that you take an element from each of the differences and then you multiply them together. And that means that A union B isn't a group, because the union doesn't include... Yeah, like it doesn't include that product, I guess. That's the approach I do, but we don't directly prove A union B is not a group. Maybe you will. Okay. Yeah, sure. I'll put down my train of thought, and then if you point out a mistake, I'll try and fix it, or I'll just ask you what your approach is. All right. So A and B be proper subgroups of G. Let's throw out the cases that are non-starters. Cannot be that A equals B because A union A equals A, which is not equal to G. It cannot be that A is a proper subset of B because A union B equals B is not equal to G. Likewise, oh, can you do a slash through that? And that's like that's okay? So say not a proper subset? So A minus B is non-empty. Well, A minus B and B minus A are non-empty. Let A belong to A minus B and B belong to B minus A. Since A is not a member of B and B is not a member of A, oh wait, does this violate closure? No, yes? No? Okay, well... Yeah, okay, yes, I think it does. AB is not a member of A, and AB is not a member of B. Or AB and BA, I guess we should say. Don't assume commutativity. Aren't an A or B. But A and B do belong. A and B do belong to A union B. Since AB and BA, I mean, we really only need one of them, do not belong to A union B. A union B cannot be a group since it is not closed. That's my idea. I probably could have worded it better. I think you're right. Ooh, awesome. It's not a subset, not necessarily. Oh, that's true. Yeah, I could have said more generally like subset equals. You actually want A minus B and B minus A not empty, right? Because I want to choose elements from those. It's important that it's not just a proper subset, they're not equal. Oh, okay. I mean, if it's not a proper, oh, I mean, you might have actually picked up a subtlety that I didn't. I was just going through all the possible like cases, I guess, for things that we can like easily throw out. So what was your idea then? To contradict one of the assumptions. Okay, so you also do A and A minus B and B minus A. A union B is a subgroup. Oh, okay, so you just find a contradiction with that, whereas I maybe did it more directly? Oh wait, oh, maybe then either A, B is an A, or either A, B, and A, then A inverse A, B. Oh yeah, so A, B being an A wouldn't make sense because B is in B minus A. Or AB is in B, which contradicts. Okay, nice. Saves NSPQ. Well, thank you for like giving me the start on that one, because definitely the part with the subset it was important. I don't know if I would have gotten that on my own even, so it's a nice like proof. Oh wait, there's a second part to this. Does the statement remain true if 2 is replaced by 3? Can't you do the exact same argument for why 3 doesn't work? Yeah, because like you could even take like, you know, B union C and take that as your second group in the proof that I just wrote. You know it's false? Okay, yeah. Yeah, I think you just take the union of 2 of the groups as one of the groups in your 2-group proof. That makes sense. I'm kind of curious if the book actually supplies like a helpful proof for this one, because some of the proofs have been kind of crappy. Okay, don't scroll too far down. Suppose G is equal to the union of H and K. Pick H belongs to H with H not equal to K. I haven't defined K yet, which kind of disturbs me, but... Wait, no, that should be capital K. Hey, Stooky. It's going good. We just did a proof that I think you'll work on before. It's the one that a group cannot be the union of 2 proper subgroups. We just got to a proof that at least me and SPQ agree on. How's it going for you? Okay, so this is actually the same idea that we came up with then. It is. Wait, so 3 proper subgroups is possible. That's crazy. What the? Wait, 1, 3, mod 8 is a proper subgroup. How does that work? 3 squared is 9, which just gets you to 1. Okay. 5 squared is 20. Oh my god, it works. That's so weird. Apparently 3 is fine for some groups. I thought modular arithmetic would be like right out for subgroup for some reason, but your lean stringer boy isn't on today, so you got to figure out what to do with yourself. Oh gosh. That's weird. So why doesn't, what's the error? And like, why can't you say that? Okay, wait. What's what are integer multiplication mod 3 is it contains 1 and 2? Is that a group? 2 times 2 is 4 is 1. 2 times 1, that's a group. But 2 on its own isn't a... Dang it! All right, I guess it's just 2 is the magic number. I don't know. I'm kind of confused why the 2-group proof doesn't apply to 3 groups. HK is not an H or K, but it could be an L. I think that's the point. I guess so. For like a small enough group, I guess it can work. So if it's if it's 3 proper subgroups, you need it to be 4 elements, or maybe a multiple of 4 or something. Or maybe like of the form like 3k plus 1. And that doesn't work for 2 specifically because it means you're leaving the identity out. Whereas with 3 groups, you don't have to. I don't know. 3 groups allows for a type of overlap that 2 groups doesn't, I think. I'm not sure. You choose the third kinda generated by other products that don't lie in the union. As long as that isn't a group, or as long as that is a group, rather, I guess. But yeah. Okay, 17 was another one that was suggested. This might be my last one for the day. Using vector spaces, your intuition, you see that your guess is that the group has to be small. I know an example of more than 4 elements. I'm pretty sure it's the only abelian example. Vector spaces. Where if you keep adding columns, you're not actually helping in that. Huh. I have to think more on that vector spaces thing, though. That's an interesting thing. So a subgroup is like a subspace. It cuts out a thin line or hyperplane, so you can only get the group a tiny piece at a time. Okay. I think I can see that. But my linear algebra is not the greatest, especially when hyperplanes get involved. But I think I see the idea that you're saying, that if you I don't know, but then you get into like combinations. I don't know, maybe I shouldn't think too hard about it because I'm gonna break my brain. But hmm. I think I sort of get the idea, but anything but a lot more. I'm just gonna read 17. Each divisor k greater than 1 of n. Let u sub k of n be all x in u of n such that x mod k equals 1. This is taking a subgroup, like a second level of modding. (2D) vector space over... Stop, I have to think too much about... Oh, okay. 2D vector space over... What is a vector space over integers mod 2? Oh, as in like using the 2 unit vectors? And linear combinations of those? I don't know, maybe I feel like I shouldn't think too hard about it. Integers mod 2 cross integers mod 2. That hurts my brain. Or like that, or I guess like as in that Cartesian product being like a vector space. One, 0, 1, 1, and 0, 1. Huh. It was the example with u of 8. Oh, right, for 3 proper subgroups. And the identity would be the 0 vector. Okay, yeah. Wait, u sub 7? Oh my gosh. This is asking, this is like 5 different questions in one. This is a subgroup? So 8? Oh my god, why do they choose such annoying numbers? 8 squared is 64. What is 6? Oh, which one goes to 63? Wow, okay. I'm not even gonna bother verifying that one. Okay, fine. If I believe you, I guess the modding k equals, like the equals 1 part is probably the essential part there. I guess let's try listing these elements. Okay, we're starting with u sub 4 mod, or u sub 4 of 20. Okay, so 1 is a shoo-in. We want to, so if you mod it with 4, it should be 1. So u20 involves 1, 3, which is not right. 5, no, not 5. Not 6. 7 is not right. Not 8. 9 is right. 11 isn't. 13 is. 16, 17, but not 19, right? I'm just gonna assume that I'm right. Use of 5 of 20. One, of course. 3. 7 isn't right. 9 isn't right. 11 is right. I mean, we would only have to check 1 plus a multiple of 5. So 1 is in, 6 is not in, 11 is in, 16 is not in, nothing else has a hope of being 1 mod 5. So 4 and 5 are relatively prime, and they're the only overlap in the sets are the identity. Use of 5 of 30. All right, numbers relatively prime to 30. 30 has a lot of factors, as it turns out. 7 is not one of them. 7 doesn't work. Oh, yeah, no, just trick. We check 1, which works. 6 does not work. 11 does work. 16 doesn't work. 21 does not work. 26 does not work. Just 1 and 11? Okay. Unless I have use of 10 of 30? Is this gonna be the same thing? Because 21 doesn't work, but 11 does. I think I'm good. Prove that U sub k of n is a subgroup of U of n. Okay, so we're gonna do this proof. So 1 step or 2 step, I guess, is. I'm gonna scroll up because the book provides a really nice like procedure for proving subgroups. Oh wait, we can do the finite subgroup test, right? I want to look at this. This seems like it's what we're going to want to use here. So to prove that it's closed. But don't you have to, are there a few other things that you have to show, or is it just that? Verify that it's not empty? Okay, so let's verify it's not empty, and then instead of doing this, well, we'll assume that two elements A and B have the property P, and then I guess show that AB mod K is 1. Or something, I don't know. I just want to make sure there wasn't anything that extra. So let's start by focusing on non-empty. And then show that it's closed. One belongs to U sub K n because 1 mod K equals 1 all K greater than 1, which was given in the problem, right? Right. So U sub K of n is non-empty. Let A and B belong to U sub K of n. Then A mod K equals 1 and B mod, oh, okay, this is just going to be some modular arithmetic stuff, right? AB mod K now is equal to A mod K times B mod K, which equals 1 times 1 mod K, which equals 1. So it's closed, and that's our proof. By the finite subgroup test. Let H equals all x that belong to U of 10 such that x mod 3 is 1. It's H a subgroup of U of 10. Okay. What am I doing? I guess let's list the elements here. So U of 10 is 1, 3, 7, 9. So 1 works, 3 doesn't work, 7 works, 9 doesn't work. Well, this makes checking it manually pretty freaking easy, doesn't it? Well, that's not good. So I'd say the answer here is no, it's not a group because it's not closed. Wait, so did we just break the last proof or what happened? Or no, I must have messed something up. So I feel like I just, they wouldn't tell you to prove something and then immediately give a counterexample, right? But 9 mod 3 isn't 1. What did I do wrong? Oops, didn't mean to do that. Wait, am I stupid? I'm right that it's not a subgroup. Did I just prove a false statement? Oh, divisor of n. Okay. Okay, we didn't break math. Okay, we're good. 3 isn't a divisor of 10. That's why this doesn't work. Okay, okay. We've saved math. Okay. I think that's gonna be it for me for the day though. Oh my god, please. All right. I guess let's rate out. I guess we have both Zach and Gold here. I rated Zach more recently, so let's rate out to Gold. Oh wait, you know what? I did just know Physics and Depression is on too. Oh my god, we have so many friends. Physics and Depression was just here today, so let's rate out to Physics and Depression. Yeah, hope you have a good night too, Stooky. Thanks so much everyone for hanging out with me. It was a fun day. Oh, I need to stop the YouTube.